All right, welcome to another video for AP Computer Science Principles. All right, my name is Daniel Bonarigo, and I teach at Riverside Brookfield High School in Riverside, Illinois. I've been teaching AP Computer Science Principles from the very beginning. I was one of the teachers who was fortunate enough to teach it during the pilot years, the year before it became an actual AP course, and I've been teaching it ever since. I've also had the opportunity to serve as an AP Computer Science Principles reader, so reading and grading AP tests. Also served as a table leader for a number of years, and so I'm really excited today to be sharing this video on how to complete and submit your files into Digital Portfolio to have your performance tasks graded by the College Board. All right, so lesson overview. So today, what you will learn during this presentation is what you need to submit for the Explore performance task, what you need to submit for the Create performance task, and then how to make sure that you create PDFs on your device, depending on what type of device you're using, and then making sure that you can create video and potentially converting video file types if you need to do that. All right, and then lastly, we'll be talking about going through how to submit your files to the Digital Portfolio, the College Board's website, where you are required to submit in order to be graded. All right, and so that's what we'll be going through during this presentation. All right, so what you need to know. All right, so first of all, what you need to submit for the Explore performance task. Now, this is in the Explore performance task directions. All right, but you need to submit two things. All right, so number one, you need to submit a computational artifact. Okay, now this is to be either a PDF file or an audio or video file. All right, now if you choose to do a PDF file, it must be 3 pages or less. All right, a lot of students choose to do a PDF file, which is kind of like the way I think about it, maybe like a digital poster board or something like that, where they include pictures, a title, some text, some arrows, something like that, which is showing the computing innovation that they've selected and outlining its purpose, function, and or effect. So that would be if you chose a PDF file. Now, if you've chosen an audio or video file, okay, you have to make sure that you pay attention to the file type that you are recording. All right, now the file type must be either an MP3 audio, MP4 video, WMV, that would be like a Windows media file, all right, an AVI or .mov, right? Those are all video files, those four. And then you have a WAV file or an AIF file, which are other versions of an audio file. Okay, now depending on whether you choose audio or video, right, you need to make sure that you are choosing a way to record that is going to be one of these file types, or potentially you may have to convert one of whatever you record into one of these files. Now, luckily, there are a lot of different ways that you can convert a file type. So let's say that you record a file that is not of one of these types. You can very easily just type into like a Google search bar, whatever file type you have, and then TO, and then let's say you wanted to convert to M4, right? And then you could easily pull up a website that will convert that file for you and then download a new file type. All right, now when you do create this, okay, and you get it in the appropriate file type, it must be less than 1 minute in length and less than 30 megabytes in file size. So you want to make sure that you do that. The Digital Portfolio system that you are submitting to will not accept an audio or video file that is larger than 30 megabytes or longer than 1 minute in content. So it's very important that you understand that. Okay, if you try to submit a file that is more than 1 minute or more than 30 megabytes, the system will give you an error and it will not allow you to upload that file. So very important that you pay attention to that. All right. Now, when you are recording your audio or video, obviously just make sure that it's less than 1 minute in record, and you don't even have to get to like, a lot of students try to get to like 59 seconds. Or, it's fine to be 55 seconds or something like that. Make sure that it is not 1 minute. All right. So that's the first thing that you need to submit, computational artifact. All right. Number two, the second thing is written responses. Okay. Now, written responses are going to be a PDF file. That is the only file type that is going to be allowed, and you should have clearly labeled responses to 2A through 2E from the task description. So remember, in the task description, it said you need to respond to 2A, 2B, 2C, 2D, and 2E. These are 5 different prompts that you have to respond to. Okay. Then you need to, when you're done typing those, then you need to convert it into a PDF file. Now, depends on what program you're using, but no matter what program you write it on, you could always bring it into Google Docs or Microsoft Word or something like that. Google Docs is what I recommend, and it's very easy to download whatever file you have in Google Docs into a PDF file. So we'll talk about a little bit more about that later. So that is what you need for Explore: computational artifact and written responses. So 2 separate files in order to submit in Digital Portfolio. Okay, what you need to submit for Create. So for Create, there are 3 things that you need, 3 separate file types. All right, number 1, you need to have a video file. No audio is allowed, no PDF is allowed. You may only submit a video file. Now, the file types that are allowed are only MP4, WMV, AVI, or MOV. Right, these are the only types that are allowed. And just like for the Explore video, if you chose a video, it must be less than 1 minute in length and less than 30 megabytes, just like that other one. Now, what you need to remember, right, is that you do not need to show the entire program run when you are creating this video. Okay, a lot of students think that they need to show every different way that the program that they've created could turn out, every different choice that the user could make, every different iteration that could happen. That is not the case. All right, you need to show a significant feature of the program running, right, and the video must be less than 1 minute. So please, okay, keep it under 1 minute. Remember, the system, Digital Portfolio, will not accept a file that is longer than 1 minute in length or greater than 30 megabytes in size. All right, so that is the first thing. You need to create a video of your program running. Now, when you are creating this video, right, you could use a variety of different ways to do this. I've seen students use a screen recording. So they have their program running on their laptop or desktop or something like that, and then they use a screen record tool such as Screencastify or Screencast-O-Matic or something like that, or you could use like a QuickTime screen recorder, something like that. Just depends on what you're using. Right? I personally recommend Screencastify. It's very nice. It syncs very well, but you need to use a Chrome browser to do so. Right? Now, I've also seen students who just take a mobile device like a phone or an iPod Touch or an iPad or something like that, and they run the program on their phone and then, or sorry, not on their phone, on their desktop or laptop, and then they just use the camera on their phone to record that. That is just fine as well. Right? All right, so that's number 1. You need to have a video of the program running. Number 2, written responses. Okay, this is a PDF file, just like the written responses for the Explore performance task. 1 PDF file, clearly labeled responses to 2A through 2D from the task description. Right? Now, remember, for Create, for 2C and 2D, you also need to include code segments for what you're talking about in 2C and 2D. So make sure that you copy and paste those code segments in, or you do like a screenshot or a picture or something, and you insert them into your document. Okay. Now, once again, I recommend typing these responses in Google Docs or something like that. And then once you have put everything into them, then you can click File, Download as PDF, and then you'll have a PDF file. Right? And then number 3, what you need to submit for Create is your entire program code, and that needs to be in a PDF file as well. Okay. So you need to take your entire program code and you need to copy and paste. If you're using like a text-based language, copy and paste works very well into like a Google Docs or Microsoft Word or something like that, and then you export it as a PDF file. All right. Or if you're using a block-based language like Scratch or Snap or App Inventor or something like that, then you want to use some sort of a screenshot, and then you can paste those screenshots, or insert screenshots, or even take pictures with your phone or whatever you have to, and insert those into a document, and then you can download PDF file. Now, don't forget to include an oval around your algorithm for 2C and a rectangle around your abstraction for 2D, just to identify where in your program those pieces actually fall. Right? So that is what you need to submit for the Create task. All right. So now, creating PDFs on your device. I talked about this a little bit. All right. But here's my recommendations. All right. So if you're on a Chromebook or a PC or a Mac, I would create and edit my responses in Google Docs. All right. Then I would click File and then Download as, and I would select PDF. All right. So that is just my personal recommendation. That is what I found to be very easy. And once you download PDF, then then you'll be able to submit that file to the College Board. Right? Now, if you do not have a Chromebook, a PC, desktop, Mac, something like that, and you are using like an iPhone or an Android device or like a tablet or something like that, I would recommend downloading the Google Docs app and then create and edit your responses in Google Docs. And then what you're going to do is you're going to click the three dots in the upper right corner, and you're going to click Share and Export, and then you're going to send a copy, and you're going to select PDF, and then save the files. All right. Now, it might look like this if you're on a phone. You see the three dots in the upper right corner right here. Then it's going to pop up this, and you're going to click Share and Export, and then I would choose Send a Copy, and then you'll select PDF. Right. So that is a really quick, easy way to use Google Docs to create a PDF. All right. Now, creating video files. All right. So now, if you're creating a video for Explore, so remember, if you're creating a video for Explore, you are most likely, recording something in your, house or yard or whatever. All right, to provide an illustration representation of the computing innovations intended purpose function. Right. So I would recommend just using your mobile device. Right. If you use an iOS device like an iPhone or iPod or iPad, something like that, you record it. It's going to be a .mov file type, which is acceptable. If you're using Android, okay, same thing, tablet, Android phone, something like that. All right, it should save it as an MP4 file, which would be acceptable files. All right. That's if you're using Explore. Okay. Now, when you're creating a video for Create, remember you have to take a video of your program running. So now you have to think, how are we running the program? All right. So either you're running the program on a Chromebook, a PC, or Mac, something like that, some sort of laptop, desktop, computer, or potentially you're running it on your device, an iOS, an Apple, an iPhone, something like that, or on an Android device, something like that. All right. Now, if that is the case, you're going to have to do things like that. Now, if you are running it on a Chromebook or PC or Mac, something like that, okay, you run the program in your integrated development environment, right? Whatever you're using, right? You run the program, and then I would recommend using Screencastify's Chrome extension to record the screen. Okay. Now, I said you could also use like Screencast-O-Matic, or there's some other screen recorders out there. Personally, I recommend Screencastify. So if you're using Google Chrome, okay, that's the browser that you're using. Now, if you're not using it, if you're using like Internet Explorer or Safari or something like that, I would recommend downloading the Chrome browser and then search Screencastify Chrome extension, and then you can add the Screencastify extension, and it's very easy to record your screen. Now, when you do this, right, you're going to select the Screencastify extension, right? You're going to come down here, and you're either going to record your desktop or your browser tab, depending on where your programming environment is, all right? And then you're going to record, right? Now, once you do that, okay, the video will pop up after you stop the recording, and then on the side, what you're going to do is automatically going to save to your Google Drive, right? But then what you want to do is you want to go down here, click Download, and click Export as MP4, because MP4 is the file type that you want. Okay. Now, the other thing that I would say is, or you could just use a mobile device to record. So if you guys are running the program on your Chromebook or PC or whatever, then just use your phone and record what's going on the screen. That's a pretty easy way to do it as well. Now, if you are programming on your iPhone or iPad or something like that, then what you want to do is you want to run the program, but then you want to record the screen using a screen recorder. Now, Apple has a screen recorder built in. All right. So what you want to do is you want to go to Settings, Control Center, Customize Controls. So follow these directions, right, and then you can record your screen. These directions are available on this Apple support page. Okay. On Android, right, once again, you're going to run the program on the device and you're going to record the screen, but you're going to be using some of the tips that are available at this URL that given down there. All right. Either way you do it, all right, you have to get that file type as one of those four that I showed you earlier. Okay. Now, once you do that, now you're going to have to go to Digital Portfolio. So here's the link to Digital Portfolio, so digitalportfolio.collegeboard.org. You're going to want to go there. You're going to have to log in with your credentials. So I'm going to click over here, okay, and I'm going to log in. Okay, I think I'm actually already logged in. Okay, so I'm logged in, all right, and it's going to take you here. Now, you're going to have some of these classes listed. Okay, now these classes listed. Okay, you might not have all of your AP classes listed, but you have to have AP Computer Science Principles. So you're going to click over there. Right now, when you're on here, the first thing that I want you to focus on is this table. Right, so you have this table here. Okay, this shows right now no draft, draft in, no draft. Now, when you first log in, it's going to look like this, right, where you have no drafts. Right, you have not submitted anything. Okay, now this overview page has just some basic information. Also has some links to information here. All of this is important stuff. Okay, we're going to focus on actually submitting the documents that you have created. Right, so this is on the overview. Okay, now let's keep going. All right, so submit and create files. Okay, number one, you're going to click create on the left side, and then click individual video. All right, so remember, okay, it looked like this, create. Then you click that, it'll pop out these other choices. So there's an overview for create, individual video, individual written responses, and then program code. So I'm going to start off by clicking on individual video. Okay, when you click on individual video, you're going to see a place, okay, that says upload new. So file, upload, and submission, upload new. So you're going to click on upload new, and then you're going to select your file, and you're going to upload. All right, now you're going to repeat steps 1 through 3 for individual written response and program code. All right, so if I go back to my digital portfolio, all right, I click on Computer Science Principles. All right, I click on create. All right, individual video. Right now, it's going to say upload new, right, or individual written responses. Okay, upload new, or program code, upload new. Right, so you're going to do all of that. Okay, then you're going to go to explore. Right, you're going to click on. You can click on overview. You can look at that computational artifact. Okay, now this is a place where I've already submitted something, so I'm going to show you that in just a minute. But then individual written responses, you're going to click upload new. So you're going to upload all 5 of your files. Okay, all right, so let's keep going here. So we've submitted our create files. Now submitting explore. Remember, you only have 2 items to submit for explore. So you have the computational artifact. You're going to click upload new, select the file and upload, and then you're going to do it again for written responses. So remember, create. You've got the overview, computational artifact, written responses. You're going to upload new. All right, now you have all 5 files. Right, so you're going to see triangles here now. Now mine all say no draft yet, but after you've submitted each of those files, you're going to have a triangle here. Okay, now you saw on my digital portfolio, I did have a triangle here because I had already submitted a file in the computational artifact. Okay, now you still need to submit as final. So now you go to each of the 5 files that you have submitted. All right, so remember, if I've already submitted a particular file, okay, all right, if I've already submitted a file, okay, I'm going to be able to submit it as final. All right, so now when you click over to, let's say, individual video, okay, and you've already submitted a file, you're going to see this, okay, where it's going to say upload new, download latest, or submit final. So now you're going to have to go here and click submit final. Okay, now when you do that, okay, you must click view file. So when you click submit final, this thing is going to pop up. Okay, now notice there's these 3 things that you're going to check. You cannot check them until you click view file. So the College Board is asking you once again, okay, you submitted this file, but now I want you to verify this is indeed the correct file. Right, so you click view file, it will download your file, and so then you want to check to make sure that that file is the one that you want and that it is actually working correctly. If the video, of course, you want to make sure that it is working properly. All right, once you have clicked that, then you will be able to click these boxes. You must check all these boxes. Okay, you're going to click next after you check the boxes. Then this is going to pop up. It's going to say final submission. Then once again, you must check all of these boxes. Once you check all of these boxes, then you click submit. When you click submit, you're going to see a check mark on the overview page. All right, so that is completing and submitting all of your documents. All right, so at this point, after watching this video, you should understand what files and file types you will need to submit for both the create and the explore performance tasks, how to create PDFs and videos on your device, how to access digital portfolio, and how to navigate and submit files on digital portfolio. Once again, we know that not all students have access to the internet or to a device. We're working on solutions to help students get what they need to show their best work. If you need mobile tools or connectivity or know someone who does, you can reach us directly to let us know. Go to the URL cb.org/tech to make sure that the College Board knows that either you or someone you know does not have access to a device or the internet. Thank you so much for watching. Hello, welcome to another video for AP Computer Science Principles. My name is Daniel Rodrigo, and I teach at Riverside High School in Riverside, Illinois. And I've been teaching AP Computer Science Principles since the beginning of the AP course. I was lucky enough to be one of the pilot teachers to teach the course before it was an official AP course, and then I've been teaching it ever since. I also have the pleasure of working as a Computer Science Principles reader, and I've been a table leader for a number of years, and I will continue in that capacity this year to score the AP Computer Science Principles exam. Right? So this video is going to be talking about scoring the create performance task. All right. So what you will learn in this presentation is where to find sample create responses, where to find scoring commentary about the sample create responses, and then we're going to go through some examples of scoring the sample create responses using these scoring guidelines, and then we're going to have a little bit of practice scoring some sample create responses. All right. So I just want to point out a couple things. All right. So here at this link, all right, you can, if you want to, you can take a screenshot to get these links, or these links will be available in the description of this video as well. But if I click on this link, I want to show you what is available at this URL. All right. So this talks about the Computer Science Principles exam, and this is on AP Central. All right. So if I scroll down a little bit, you see all sorts of information about the exam, digital portfolio, directions, all of these items. But what I really want to direct you to all the way down here is where to find all of these samples. So you see all of these here are samples of Explore. All of these here are samples of Create. We have the scoring guidelines, which I gave you that link in the previous slide, and then also the Explore commentary, the Create commentary, and then the scoring distribution to see how students actually did on the 2019 AP Computer Science Principles exam. All right. So we're going to be focusing today on the Create samples, and then we're going to be using the scoring commentary. All right. So if I go back here, all right. So I just showed you where to find sample Create responses, and also where to find the scoring commentary. But if you just click on this link, you're going to see the scoring commentary. All right. So this is a PDF document, all right, which is going to have a whole bunch of samples. It also has the scoring guidelines, which we will be using today. All right. And then here's, if you keep going down, this is where the samples begin. Now I'm not going to go too far down because I don't want to give you a sneak peek of what we're going to be doing. All right. But anyway, and then like I said, here is a link to the scoring guidelines, and we're going to be focusing specifically on pages 2 through 4 of the scoring guidelines, which are Create. All right. And then we're going to practice scoring. So I'll give you an opportunity to pause the video when we're going through some samples and decide for yourself before I reveal yours. All right. So what you need to know. All right. So this is where we're going to go through an entire sample so that you understand exactly how AP readers would have scored this particular response. All right. So first of all, okay, this is sample A. All right. We're going to go through sample A in its entirety. All right. And so now we will look over here at row 1. So row 1 says the video demonstrates the running of at least one feature of the program submitted, and the response, either audio narration or written response, identifies the purpose of the program, what the program is attempting to do. All right. So here's the video. So we're going to go ahead and play that. All right. So you see student hits run. You can see they've created some sort of a game where they drive this car around and they're running into these yellow things, right? Picking them up as they go. And you can see there's some numbers down here, right? So this is the video that a student submitted. All right. All right. And then they restart, and then they're going to show some more. All right. So now, all right, would the student earn row 1? All right. So row 1, the response earns the point for this row. The video demonstrates the running of the program. Okay. But now remember, okay, if I go back here, it must also, right? It says, and the response identifies the purpose of the program. All right. So you have to look at 2A or the audio narration. That particular student did not have audio narration. All right. So the student wrote, the programming language that I used to create my program was Alice. The purpose of my program is to be an entertainment game and functions by requiring the user to collect 10 orbs using the spaceship to win. If this requirement is not met, the user can try again. The video demonstrates the start of the game by asking the user if they would like to play or not. If yes, then the game would start. If not, then the spider robot can just free roam. In the first try, the spaceship collects all orbs and gets launched up into space. The second try, the spaceship does not collect all the orbs in time, and the user is asked if they want to try again. I click no, and the game stated game over. But if yes was pressed, the game resets. The variable's time and points are displayed below the program. All right, so have they stated the purpose? Right. So video demonstrates the running of the program, and the purpose of the program is to be an entertainment game and functions by requiring the user to collect 10 orbs using a spaceship to win. So yes, the student earned row 1. All right. Same sample. All right. Now response to B, talking about the development of this. All right. So student wrote, I independently made the whole program. In the beginning, I wanted to make a game about collecting items. First, I assembled a list containing the orbs that will be collected as the points spared. Then I assigned arrow controls to the spider controlling the spaceship. I thought about setting it up so when the spaceship is within the threshold of an orb, that orb will sink down and 1 point will be added. I also added a point limit that must be met to win. My game was too easy, and it would decide whether it uses wins or loses. So I took the opportunity to add a time. I did this by making a time variable and decrementing 1 off of it every second. The game is decided when the time equals 0. A difficulty I encountered while creating my program was how to restart the game, not the program. Every time I press try again, the whole program freezes. To try to overcome this, I messed around with the order of code until I solved it when I reset the variables to its original values, because when I click try again, the conditions were still met. So have they earned rows 2 and 3? So remember, row 2 describes or outlines steps used in an incremental and iterative development process to create the entire program. Remember, incremental means step by step. Iterative means going back and fixing or rewriting or changing code due to some testing, observation, or feedback. All right. Row 3 specifically identifies at least 2 program development difficulties or opportunities and describes how these 2 identified difficulties or opportunities are resolved or incorporated. The answer is yes. The student did earn rows 2 and 3. So let's look. Row 2. The response describes the incremental process of developing the program. In the beginning, I did this, and I did this, and I did this. The iterative process is made clear in the difficulties and opportunities. Right? Row 3. The student did earn the point for this row. The response identifies an opportunity and a difficulty. My game was too easy, right? So I took the opportunity to add a timer. Right? A difficulty I encountered while creating the program was how to restart the game. Right? So they talked about what their difficulty or opportunity was and then how they resolved. So this student earns rows 2 and 3. All right. Let's move on to response to C. All right. Response to C. Okay. So this is the code that the student identified. All right. And we can flip back to this. But okay. The student wrote, my main algorithm world.start uses sequencing by setting up the spider into spaceship. All right. So if I go back, world start is over here. So this is the algorithm that they are defining. Okay. This method uses logic by using an if else and yes or no function to decide if the player wants the game to start or not. My main method world start functions by asking a yes or no question about if the user wants to play. Depending on the answer, the spider will either be put into the spaceship yes or put into free roam no. The purpose of world start is to be an introduction and a choice for the user if they want to play or not. The main algorithm includes 2 sub-algorithms, world game and world finder. So if I go back, you see world game here, right? And then world finder over here. Okay. The main algorithm includes 2 sub-algorithms, world game and world finder. One of the sub-algorithms, world finder, uses math by making it so that when the jet is less than 5 meters from an orb, the orbs list, the orb will add a point and make the orbs disappear. The other sub-algorithm, world game, uses math by using randomizers to set the position of all the orbs in the orbs list between moving forward 75 to negative 75 meters and then moving left 75 to negative 75 meters every game. All right. So has the student earned rows 4 and 5? All right. So row 4, remember, the selected code segment implements an algorithm. Now remember, row 4 is really easy. Row 4 means they picked some portion of the code that is more than one line of code and less than the entire program. So the answer is yes for sure here, right? Obviously, but row 5 is a little bit more challenging. Row 5 says, okay, the selected code segment implements an algorithm that uses math and logic and explains how the selected algorithm functions and describes what the selected algorithm does in relation to the overall program. And so the answer is yes. The response includes an algorithm that has math or logic, if and while. The response states my main method world start and so on. That first few lines. The response describes what the algorithm does in respect to the entire program. World start is to be, right, and so on. And so this student has earned row 5. Right, but what about row 6? Right, so row 6, remember, row 6 says the following. The selected code segment implements an algorithm that includes at least 2 or more algorithms, right? These have to be sub-algorithms contained within the main algorithm, and at least one of the included algorithms uses math or logic and explains how one of the included algorithm functions independently. All right. And so, okay, let's go down here. Row 6. Yes, the student does earn the point for this row. The response gives an algorithm, right? World Start, of course, that uses two algorithms, World Gain and World Finder, right? These are the sub-algorithms. The response explains how World Finder works, uses math by making it so that when the jet is less than 5 meters from an orb, the orbs list, the orb will add a point, and the orbs disappear. So we look, okay, it has two or more sub-algorithms. At least one of them uses math and logic, and they've explained at least how one of the included algorithm functions. And this student explained how both of them function independently, but they would definitely earn row 6 for this one. All right, moving on to response 2D. All right, so this is what the section of code that the student identified for their response 2D. All right, so let's read what they wrote for response 2D. World.winner and reset was made by me independently to be able to check and decide whether the player wins or loses. It also gives the user the choice, if they lose, to either restart the game or accept defeat. I created this method so that the user can only win if the variable coins equals 10. I created the restart function by replaying the method world game method, which is the setup of the orbs placement and then restarting the variables. This abstraction, world.winner and restart, manages complexity of the program as it breaks down how the winner is decided. It also makes it so that when the game is restarted, the code to make the game work the same way as when it was just started without having to be written again. This method hides all of these complex instructions that makes the game replayable. The name also clearly explains the function of the method, so as it says that the method holds the instruction to decide the winner and to restart the game. All right, so row 6, 7, and 8. All right, so row 7 says the selected code segment is a student-developed abstraction. Row 8 explains how the selected abstraction manages the complexity of the program. So this student, of course, has earned row 7 and 8. Row 7, okay, the boxed code segment in the response represents a valid abstraction, a procedure or method, okay, or a function or whatever your programming calls it. All right, and then row 8, yes, the student did earn this. The response explains how the abstraction manages the complexity of the description when the game is restarted. And so, all right, so this is a good response about a student-developed abstraction and explaining the management of complexity. All right, so that is sample response 8. All right, so this student earned all 8 of the rows for the creative points task. All right, so now we're going to do a little bit of guided practice. And so I'm going to show you a sample of either 2A, 2B, 2C, 2D, and then we are going to, you can pause the video and then you can decide whether or not the student earns a particular point. All right, so this is sample C, and we're going to be practicing scoring rows 2 and 3. All right, so a student wrote in sample C, the incremental development process of my program was to first acquire an idea. My first difficulty arose when I chose the game Tetris, but couldn't figure out how to implement an idea that I had in my mind. I decided to ask my partner for help, in which he suggested that I pick a different game, like the snake game. I decided to go with the snake game. My first process was to create a sprite that moved, and I did that. After that, I had to make the sprite move in the direction I wanted it to, and using the press key block and direction block, it worked. After brainstorming ideas and implementing them, such as creating a target and making a target move on impact, I ran into a problem. Whilst trying to use the clone block to make my snake grow in size, it kept touching itself, causing it to go to the game over string. After testing multiple times over and revising the code, I finally fixed it independently by changing the structure of my code by using a previous code segment that I had after this. My program worked perfectly, and it was finally done. All right, has the student earned rows 2 and 3? All right, so keeping in mind, row 2 says the student describes or outlines the steps used in the incremental and iterative development process to create the entire program. And then row 3 specifically identifies at least 2 program difficulties or opportunities, describes how the 2 identified difficulties or opportunities are resolved or incorporated. All right, so go ahead, pause the movie and decide for yourself. All right, so row 2. The response earned the point for this row. The response describes the development process, okay? But the first part really wasn't the development process. This was the idea for the project. So remember, this first couple lines wouldn't really be part of the incremental process. They don't really start talking about it until they decided to go with the snake game. So they wrote, my first process was to create a sprite that moved, and I did that, right? And so that's where they talked about the incremental development process. Now, what about the iterative development process? Well, the iterative nature of development is also evident in the response after testing multiple times, right? So after testing multiple times, they had to go back and had to make some changes, fix some things, and then they talked about how they resolved. All right, so that is row 2. But what about row 3? The response identifies only one difficulty and resolution, right? They did not identify 2 difficulties or resolutions. And so the student did identify whilst trying to use the clone block, right? And so on, okay? But they never talked about another difficulty or another opportunity. So this student did not earn row 3. All right, let's do another example of scoring rows 2 and 3. All right, so this is from sample E. All right, so the student wrote, both developments were individual. When writing my code, I ran into the trouble of what to name the pictures so that they can be randomly picked by the computer. At first, I named the pictures fruit names because that is what they were displaying. This made it difficult for me to randomize the computer. I tried using an array and then randomizing it with a random number command by using the array list. I realized that I could increase efficiency by naming the pictures as numbers. I assigned each picture a number and then used random numbers so that the computer could have a randomly assigned picture. Then the computer number could be compared to a user input of 1, 2, or 3. Another difficulty I had was with the development of the user interface. On the results screen, the score would not display. At first, I thought it was a problem with my code. I made sure the link from the functions was correct and the number should display. Afterwards, I realized the text box was not large enough for the number to display. All right, so have they earned rows 2 or 3? Have they just described the incremental and iterative development process? Have they specifically identified at least 2 program difficulties or opportunities and describe how they were resolved or incorporated? So go ahead, pause the video and decide for yourself. All right, so let's look. Row 2. The student did not earn the point for this row. Why not? This does not describe or outline the process, the steps used in the development process. Why? Okay, they said when writing my code, I ran into, right? They really are talking about a difficulty right off the bat, right? And then when they go down here, they talk about the score would not display, right? So they haven't been talking about the incremental and iterative development process. They simply kind of went right into difficulties or opportunities. So row 3, yes, the response did earn the point for this row. The response identifies one difficulty, what to name the pictures. This was resolved by assigning each picture a number. The response also mentioned a second difficulty, the score would not display. This was resolved by realizing the text box was not large, right? And so yes, they identified the difficulty, opportunity, and how they resolved, but they never really talked about the development process. All right, so that is rows 2 and 3. All right, so let's move on and let's practice scoring rows 4, 5, and 6. All right, so this is from sample D. All right, and so the student states in 2C. I'm sorry, I wanted to show you the code first, right? So this is the code that the student identified. So they have this function called game, right? And then in this function is the move basket function and the move apple function, and they've shown those 2 functions as well. All right, so let's see what the student wrote. My function game calls both the move basket and move apple, which are both student developed functions. Game makes sure the other functions are both functioning. Move basket utilizes mathematical as well as logical concepts to identify the position of the basket and move it using arrow keys. It also sets the basket's position and makes sure the basket is restricted inside of the screen so it doesn't go off. Move apple uses a loop to set the speed of the falling apples as well as call another function known as check collision, which resets the position of the apple once it reaches the minimum height, also using mathematical concepts and if statements. Both algorithms are essential because without the first algorithm, the basket would be static and would go off the screen, and without the second algorithm, the apple would be static, therefore defeating the whole purpose of the game, which is to catch the apples with a moving basket. All right, so has the student earned rows 4, 5, and 6? All right, so just a reminder, row 4, the selected code segment implements an algorithm. Row 5 and 6. Okay, row 5, the selected code segment implements an algorithm that uses math or logic and explains how the selected algorithm functions and describes what the selected algorithm does in relation to the overall purpose of the program. Row 6, the selected code segment implements an algorithm that uses at least 2 or more algorithms and at least one of the included algorithms uses math or logic and explains how one of the included algorithm functions. All right, so go ahead and pause the video and decide for yourself if this student has earned rows 4, 5, and 6. All right, so row 4, the response earns a point for this row. The code that is given represents an algorithm. Remember, row 4 is a very easy row. You have to select more than one line of code and less than the entire program. All right, so row 4 is fine. All right, what about row 5? The response did not earn a point for this row. Why not? The response does not identify clearly which is the main algorithm. There is no relation to the overall purpose for the game function, which seems to be the main algorithm based upon the paragraphs first set. And there is no explanation at all of the game function. Instead, the response focuses on the sub-algorithms, which are otherwise unrelated. Row 6, okay, the student did earn the point for this row. Why? Well, because the response gives an algorithm that uses 2 sub-algorithms, move basket and move apple, and has explained how both of those functions work in relation to each other and to the overall program. All right, so that is row 6. So the student did earn 4, not 5, but then yes, did earn 6. All right, so let's do another practice of scoring rows 4, 5, and 6. All right, so here is the code that was used for sample J. Okay, all right, and so the student writes, this is for the drop-down menus. It uses math. So for example, on the first question, it asks, who's your favorite YouTuber? On every question, it says it's YouTuber name. That's such a good choice, except for Shane Dawson, which says it's Shane Dawson. OMG, he's my favorite too. I used math for that by using the plus math block to piece together the message and the double equals, so it puts the different message for Shane Dawson. All right, so that's what the student wrote for 2C. How they earned rows 4, 5, and 6, keeping in mind row 4, selected code segment implements an algorithm. Row 5 and 6, selected code segment implements an algorithm that uses math or logic, explains how the selected function algorithm functions. This describes what the selected algorithm does in relation to the overall purpose. Row 6, selected code segment implements an algorithm that includes at least 2 or more algorithms. At least one of the included algorithms uses math or logic and explains how the included algorithms function. All right, so let me bring back the code just for a second. All right, so you see some math and logic in there. All right, so now has the student earned these points? Go ahead, pause it and decide for yourself. All right, so row 4, the response did earn the point for this row. The selected code segment provided is an algorithm, right? Remember, it is more than one line of code and less than the whole program. All right, but what about row 5? The response did not earn the point for this row. Why? The code segment identified in the response uses logic if statements, and the response explains how the algorithm works. Okay, but the response does not describe what the algorithm does in relation to the overall purpose of the program. All right, what about row 6? The response did not earn the point for this row either. The code segment that is included in the response does not include an algorithm that incorporates 2 additional algorithms. There are 2 different on events, but they are not incorporated in a main parent algorithm. So let me go back just to show you this. All right, so when we're looking at this is the algorithm that was selected, but notice this first on event is its own algorithm, and this on event is its own algorithm. They are not sub-algorithms. They are not part of some bigger algorithm that was identified. All right, and so that is sample J, rows 4, 5, and 6. All right, so let's continue on. Let's do some practice scoring rows 7 and 8. All right, so rows 7 and 8. All right, so first of all, we have to show you the abstraction that the student created. All right, and so this was the piece of code that the student identified for sample F. All right, so sample F, the student wrote, my abstraction uses loops to stamp the sprite to the stage, creating part of the column. As the code progresses, the costume is switched to create terrain later, then changing the Y value of the sprite by a small amount to add height to the column. When the column reaches its determined height by the algorithm, the loops in the code will change its X value and rerun the code to create a new column with another randomly generated height. All right, so has the student earned rows 7 and 8? So I'll bring the code back up here. All right, so row 7. Okay, the selected code segment is a student-developed abstraction. Okay, that's row 7. Row 8 explains how the selected abstraction manages the complexity of the program. All right, so let's go ahead, pause the video, and decide for yourself if the student earns rows 7 and 8. All right, so let's read row 7 and 8. Row 7, the response did not earn the point for this row. The selected code in the response is a control structure, not a student-created abstraction. All right, so using a loop or a if-then or something like that, that is not a student-developed abstraction. That is a control structure. So this is not an abstraction. All right, row 8, the response did not earn the point for this row. The response does not discuss how the abstraction manages the complexity of the program. It explains what this line of code was intending to do, but doesn't talk about managing complexity. How has the program become less complex or easier to manage or easier to debug or whatever, right? So this student does not earn rows 7 and 8. All right, so to debrief and summarize, okay, what did we cover? All right, you should understand where to find sample responses and scoring commentary. So remember, the links at the beginning of the video or also in this description are where you would find sample responses and the entire scoring commentary. We only went through kind of a small portion of it. All right, then we discussed how each row of the performance task will be scored, right, according to the scoring guidelines, right? And then we gave specific examples of samples not earning credit on particular rows so that you make sure that you realize some pitfalls that past students have had earning particular rows of the performance task. All right, and so that is all of the items that we are going to cover. Remember, those links to scoring commentary and scoring guidelines are in the description of this video, but also available at the beginning of this. Also, I want to leave you with a song that my friend wrote and recorded about the create performance task.
Write a line of code, make an algorithm ready to explode. Math and logic are a set of sharing, minors pairing, all you daring, build the app with your abstraction. Hide the details and your users will have fun. Knowing nothing of the code that's how it's providing when the data is simple to them. C stands for computer, S stands for science, principles.
All right, and I want to leave you with this. We know that not all students have access to the internet or a device. We're working on solutions to help students get what they need to show their best work. If you need mobile tools or connectivity or know someone who does, you can reach out to us directly to let us know. Go to urlcb.org/tech to let us know if there's a student or students that need mobile solutions. All right, thank you so much for watching. Hello, welcome to another video for AP Computer Science Principles. All right, my name is Daniel Bonarigo. I teach at Riverside High School in Riverside, Illinois. And I've been teaching AP Computer Science Principles for a number of years, ever since the College Board was piloting this class, and then I've been teaching it as an AP teacher since it started. So let's see, I've also served as a Computer Science Principles reader, table leader, and I will continue in that role this year for the Computer Science Principles AP read. So today we are going to be discussing scoring the Explore performance task, right? And so what you're going to learn during this presentation is where to find sample Explore responses, where to find a scoring commentary. So each of the samples that is listed also has a commentary and shows how readers actually scored these samples, right? And we're going to be using, of course, the Explore performance task scoring guidelines. So these 3 links will be available in the description of this video, but you can go ahead and screenshot or take a picture if you want as well. But I'm just going to show you a little bit of what is available at each of these, just so you know. And then I'm going to go through some of the samples or some parts of some of the samples and give you some practice scoring some of these Explore responses. All right. So first thing I want to do is I want to direct you to this link. So I'm going to take you there. All right. And so this takes you to a page on AP Central. All right. Now it has a whole lot of information about the exam, but if we scroll down here, where I want to point you specifically is down to, you got to keep going all the way down, all right, past all this information. But this is really where you want to focus, all right, on the scoring guidelines and notes for the 2019 exam administration. But these are all of the samples. So you have all of these Explore samples, A through J, and then you have all these Create samples as well. All right. Then you have a link to the scoring guidelines, which I also have linked in the presentation. All right. You have the commentary on all of the Explore samples, and then you have the commentary on all of the Create samples, and then the scoring distribution, how students did overall on the Computer Science Principles exam last year. All right. And so we're going to be going through some of these samples today. All right. So let's go back here. All right, so that is where you are going to be finding the sample explore responses. All right, now we're going to find scoring commentary. Obviously, I said that commentary is right here, but this is also a link to that scoring commentary. So if I click that, all right, you're going to see all of the samples in this. Okay, so if I scroll down, okay, you're first of all going to see the scoring guidelines, which I also have linked there, and then you are going to see the samples. All right, so I don't want to scroll too far down and give you a sneak peek at what we're going to be doing. But anyway, here's also a link to the scoring guidelines. Right now, on this link, you are looking at pages 5 through 7 for the explore scoring guidelines. Right, and then like I said before, we're going to do some practice scoring sample responses. All right, so what you need to know. So this is where we're going to spend a good amount of time. Right, so we're going to be scoring some sample responses. Now, this is sample A from that earlier link that I showed. All right, now this is a student whose topic was facial recognition software. Obviously, they have a title. All right, you can see their image here. They have some text. All right, over here, and so we would be looking at this computational artifact in order to decide whether or not they get row 1. All right, so let's just take a look at the scoring criteria for row 1. All right, scoring criteria says the computational artifact identifies the computing innovation, which they have done, facial recognition software, and provides an illustration, representation, or explanation of the computing innovation's intended purpose, function, or effect. All right, and so if we look at this, let me go back here, we see that they show a mapping of the face, and then it shows matching to a particular person. All right, and so this student, okay, would earn the point for this row. Computing innovation is identified. The computational artifact uses an image of facial recognition software and arrows to point to the metrics that are being captured. And so, all right, so that student would have earned that. All right, so now we go to the response. All right, so this is once again sample A. Now we're looking at what the student wrote into A. So the student wrote, the computing innovation represented by my computational artifact is facial recognition software. This software functions by detecting a face in an image or video that is matched with known faces in a database for identification. Now, this one right here is actually them referencing something that they've done in their research. So we'll talk more about that. That relates to row 8. Is the purpose to then identify individuals in the image or video which may be used for security measures and catching crime. My computational artifact describes how facial recognition software captures images, identifies faces within these images, and compares these faces with individuals to serve the purpose of identification. All right, so did the student earn this point? Okay, the fact is they did. Now, row 2 says that the response states a fact about the correctly identified computing innovation's intended purpose or function. So have they stated that? Yes. The response states a function about the correctly identified computing innovation functions by detecting a face in an image or video that is matched with known faces in a database for identification. All right, so they've got row 1 and row 2. All right, let's go on to rows 3, 4, and 5. Rows 3, 4, and 5 all relate to 2C. Now remember, 2B is not scored on the rubric, but the reader uses 2B to verify that the student has actually created the computational artifact. All right, so let's read 2C. One beneficial effect of facial recognition software has on society is lowering retail crime rates. The photographs of known shoplifters are matched to a criminal database. Then retail loss prevention and security are notified to prevent further crime causing rates to decrease. Notice they're making another reference here. One harmful effect facial recognition software has the potential to have on society is its misidentifying tendencies. More often misidentifying people of color. Okay, and once again, they're referencing something that they found in their research. This misidentification can lead to extreme consequences as this device is used by law enforcement and could incriminate a person, the wrong person. All right, so have they got row 3? All right, so row 3 says they've identified at least one effect of the identified or described computing innovation. So have they stated an effect? Of course, right? They stated a beneficial effect is lower crime rate. All right, so of course that is an effect. Remember, in row 3, if you go back here, they just needed to say an effect. They didn't necessarily need to identify it as beneficial. All right, so now going on, all right, to row 4. Now remember, row 4, okay, you must identify a beneficial effect. So you have to actually say beneficial effect or a synonym thereof, and identify a harmful effect. All right, so now have they stated that? Well, yes, the response identifies a beneficial effect as lowering the crime. The response identifies a harmful effect as misidentification can lead to misidentifying people of color can lead to extreme consequences as the device can be used by law enforcement, could incriminate the wrong person. All right, and so that is row 4. All right, now row 5, have they gotten that? Well, row 5 says explains how one of the identified effects relates to society, economy, or culture. All right, and so row 5 says the response explains how the harmful effect relates to society. It's misidentifying tendencies, more often misidentifying people of color. And so they have stated how this harmful effect can have an impact on society, economy, or culture. All right, and so they've earned all of rows 3, 4, and 5. All right, let's move on to rows 6 and 7. All right, row 6 and 7 relates to response 2D. All right, so what did the student write for 2D? The data that facial recognition software consumes are pictures and video through cameras capturing their images. First, the software identifies part of the image that represents the face. Secondly, the image is transformed into a format that allows all the images to have the same resolution, focus, etc. Thirdly, facial features are extracted from the image so that the software can now focus on only the most important bits of data. Now, object classification begins where software matches facial features to images. All right, so that is a very kind of lengthy part about data. So did they talk about the data that this innovation uses? Okay, so remember, row 6 says the response identifies the data that the identified or described computing innovation uses and explains how the data is consumed, produced, or transformed. All right, so if we look back here, okay, row 6, yes, the response earned the point for this row. The response cites the data as pictures and videos. Right, pictures and videos are the data type, and it's through cameras. So if the response had just said facial recognition software uses cameras, okay, that doesn't qualify because cameras are the device that captures the data, right, the pictures and the images. So remember, you have to state the data type. Right, the response explains that the data is transformed into a format that allows all images to have the same resolution, focus. All right, so that's row 6. All right, now row 7. Let's read this next paragraph. One data privacy concern is that humans will be tracked by simply going out in public. This is an invasion of privacy that would be prohibited by the U.S. Supreme Court, as in Carpenter v. United States Chief Justice John Roberts stated. A person does not surrender all Fourth Amendment protection by venturing into the public sphere. With facial recognition, this privacy is not protected because people are being tracked by their face when they go in public. So row 7, have they stated a data privacy concern? Okay, so once again, row 7 says identify one data storage, data privacy, or data security concern related to the identified or described computing innovation. And of course, the answer is yes. The response earns the point for this row. The response states a privacy concern. One data privacy concern is that humans will be tracked by simply going out in public. All right, so that's rows 6 and 7. All right, let's go on to row 8. All right, now row 8, okay, if we look at the scoring guidelines, it says that you reference through in-text citation at least 3 different sources. All right, so remember, it's very important that they reference through in-text citation. And I did point out a number of in-text citations. So notice here, they have a 1, a 2, a 3, a 4, a 5. So the reader can very easily see that when they had the 1 in their text, they were referencing this one. And when they had the 2, they were referencing this one, and 3, and so on. And so did the student earn the point for this row? Yes, of course. The response earned the point for this row. At least 3 in-text attributed citations are being used, and a corresponding bibliography is included. Of course, this is the bibliography. So that is sample response A. All right, so that student earned all 8 of the rows. All right, so now we're going to go into some guided practice. All right, so I'm going to give you an example, and I'm going to ask you to pause the video and read the example, and then decide before I show you the results whether or not a student would earn a particular point on the rows that were discussed. All right, so the first one we're going to do is we're going to practice scoring row 2, and this is from sample B, and this is about a 3D print. So their response for 2A was, my computing innovation is a 3D print. 3D printing allows its users to create their desired project by using their choice of material in a quick and efficient way. With 3D printing, new toys, custom shoes, musical instruments, arts, and airplane, and so much more can be printed to the benefit of people and society. This is done by creating a computer-aided design that instructs the printer to lay materials to its product. In my artifact, I provided diagrams that clearly outline the steps involved in this process. 3D printing is safe, easy, and reliable. All right, so row 2, did they state a fact about the 3D print, about its intended purpose or function? So pause the video and decide for yourself. All right, so the fact is that they have stated a fact, right? The response earned the point for this row. The response states a fact about the purpose of the computing innovation. 3D printing allows its users to create their desired object by using their choice of material in a quick and efficient way. All right, so that's practice scoring row 2. All right, so now let's practice scoring rows 3, 4, and 5. Now this is from a different sample. This is sample E, and this was about machine learning. All right, so student wrote, one beneficial effect of this innovation is that people will be able to keep their data more safe from cyber attacks. The automated systems that this innovation will create, as well as previous solutions along alongside automation, we'll be able to create secure systems that work very fast. The increase in detection speed will help companies to observe different methods of attacks, which will allow for companies to train their machine learning algorithms to detect more threats before they reach a wide amount of users. One harmful effect of this innovation is that the increased security will also encourage the people behind cyber attacks to create stronger attacks, which will be able to pass through more secure systems. This could make it difficult for companies to implement cybersecurity systems because they will have to keep making better and better machine learning algorithms to protect users against the increasingly strong cyber attacks. Eventually, there may be a point where the companies cannot do much more to make their systems more secure. Another beneficial effect of this innovation is that companies will save a lot of time when finding cybersecurity threats. Researchers say that up to 21,000 hours wasted each year by cybersecurity companies trying to analyze false positives and in-attack detection speed of machine learning algorithms will help to detect actual threats much faster than systems made up of only humans and software. This saved time can allow for companies to develop better security for their users as well as developing themselves as a company. So I want you to pause the video in just a moment and decide if this student has earned the points. Now remember, row 3, they've identified at least one effect. Doesn't necessarily have to be beneficial or harmful, just one effect. Row 4, they've identified specifically a beneficial effect and specifically a harmful effect. And row 5, and explain how one of these identified effects relates to society, economy, or culture. All right, so pause the video and decide for yourself. All right, so row 3, the response did earn the point for this row. The response states an effect. The increased security will encourage people behind cyber attacks to create stronger attacks. Okay, so that is an effect. Right? But row 4 now, have they actually said beneficial and harmful? Yes, companies will save a lot of time, and obviously the increased security will encourage people behind the cyber attacks to create attacks. Row 5, the response did not earn the point for this row. The response does not explain how the harmful effect is related to society, economy, or culture. All right, so that's rows 3, 4, and 5. All right, so now let's do another practice of rows 3, 4, and 5. Now this was a response regarding Snapchat. All right, so the student wrote a much smaller amount of text here, but let's go ahead and read it. It says one beneficial effect about Snapchat. It has more than 173 million daily active users who watch 10 billion videos every single day. Snapchat tells people about brand loyalty. One harmful effect about Snapchat is the Snapchat streaks because teens invest so much of their time in their streaks. All right, so has the student earned rows 3, 4, and 5? Keeping in mind what the scoring criteria is for rows 3, 4, and 5. Okay, pause the video and decide for yourself. All right, so row 3, the response earned the point for this row. The response states a harmful effect. The Snapchat streaks because teens invest so much time in their streaks. All right, now it's not very well worded, but the student would still earn this point because this is an effect of the innovation. All right, now what about row 4? The response did not earn a point for this row. Why not? The response identified the harmful effect, of course, like we said for row 3, but the response states that one beneficial effect about Snapchat is that it has more than 173 million daily active users. That is not an effect. That is actually just a fact about the innovation. So you got to remember, an effect is a result of using the innovation as it was intended to be used. Now, the fact that Snapchat has more than 173 million daily users is not an effect of the innovation. All right. What about row 5? Though? The response did earn the point for this row. The identified harmful effect of Snapchat streaks is that teens invest so much of their time in streaks, and that would mean that teens is to represent a group of society. Now, of course, this is a very short response, and yes, of course, maybe the student could have added more to it to make it a little bit better, but it would still have earned rows 3 and 5, but not 4. All right, let's go on. Let's get some practice scoring rows 6 and 7. All right, so this is sample D, and this is a response about chatbots. Okay, so the student wrote chatbots use data given to them by the company that helps them better respond to customers. This is data already compiled by the company from previous customer service encounters of the company. They use that data to develop a series of responses for the chatbots to use. One privacy concern that may come up with the use of chatbots is how they handle the data they receive from customers. They could use private information given to them in conversation to send a consumer advertisements directly targeted toward that. Companies may even tell their chatbots to sell this information to other companies for a gain in profit. All right, so let's take a look at row 6. Okay, row 6, remember, says identifies the data that the identified or described computing innovation uses and explains how that data is consumed, produced, or transformed. Row 7, identify one data storage, data privacy, or data security concern related to the identified or described computing innovation. All right, so pause the video and decide for yourself if the student gets rows 6 and 7. All right, so for row 6, the response did not earn a point for this row. The response does not identify the data that the identified computing innovation uses, only where the data is coming from. Notice it says chatbots use data given to them by the company. Well, it didn't say what the data was. It doesn't say like purchase history, how much money they've spent, where they've spent it, where it was shipped, credit card information, all of that stuff that maybe the company would be giving to the chatbot, but they didn't actually say that, so they don't get row 6. All right, what about row 7? The response did earn the point for this row. The response states a privacy issue that chatbots could use private information given to them in conversation to send a consumer advertisements directly targeted. All right, so that is 6 and 7. All right, so let's do another practice with rows 6 and 7. All right, this is a sample about a smartwatch. All right, and so the student wrote, once again, a much smaller response, a shorter response, but the student wrote the data the smartwatch uses is under a wide variety as it accesses the same data as your cellular device. The smartwatch on its own, however, detects your physical movements and ability when regarded fits. All right, so have they scored or have they earned points for row 6 and 7? So remember, row 6 identifies the data that the identified or described computing innovation uses and explains how the data is consumed, produced, or transformed. Row 7 identify one data storage, data privacy, or data security concern. All right, so pause the video and decide for yourself. All right, so row 6, the response did not earn the point for this row. The response does identify the specific data being transformed. However, the type is not specified, right? It does say the smartwatch on its own, however, detects your physical movements and ability when regarded fits. So it does talk about maybe transforming, but it doesn't actually say what type of data it's taking in. And also, this first sentence is confusing like a data package on your cellular device, like when you're actually downloading information and things, but that doesn't talk about the specific information that the smartwatch takes in. All right, so the student did not earn row 6. All right, what about row 7? The student did not earn row 7. It does not identify data storage, privacy, or security concern. You can see that there's no attempt at even getting row 7. All right, so that's row 6 and 7. All right, what about row 8? All right, so now this is a response from sample C. All right, so now if we look at this, they have this YouTube article, they have this policies and safety article, they have about YouTube article, they have another YouTube article, they have all these articles. This was only about half of the list. There was a whole lot of articles listed here, very well listed. So did this student earn point references through in-text citation of these 3 different sources? Now, I didn't show you all of the response for sample C, but the fact is that this response did not earn a point for this row because there's a bunch of references here, but there are no in-text citations. All right, so that is very important that you remember. Through some of our samples here, we've seen some of those in-text citations as we've been reading. All right, and so that is scoring row 8. All right, so debrief and summary. What have we covered in this video? All right, so at this point, you should understand where to find sample responses and scoring commentary. Remember, those links are in the description of this video as well as at the beginning of the video. How each row of the performance task will be scored according to the scoring guidelines. Remember, that link is available in the description of this video as well as at the beginning of the video. And we went through specific examples of samples not earning credit on particular rows. And so if you pay attention to where some of these samples did not earn credit, that can help you to make your responses even better and make sure that you understand exactly what you should do when you are preparing your written responses for the Explore test. So just a reminder that if we know that not all students have access to the internet or a device, we're working on solutions to help students get what they need to show their best work. If you need mobile tools or connectivity or know someone who does, you can reach out to us directly to let us know. Go to urlcb.org/tech to make sure that all students have access to a device and internet access to complete their AP tests. Thank you so much for watching this video.
Hello and welcome to another lesson in AP Computer Science Principles. I am Mrs. Julia Lano from Hamilton Southeastern High School in Fishers, Indiana. Again, I've been teaching this course since it became an AP course, and I teach plenty of other computer science courses, including cybersecurity and software development. So we're going to jump into today's lesson about data abstraction in a new programming environment. And again, we're going to go check out that MakeCode programming environment a little bit. But this lesson is about arrays in MakeCode. Arrays are also known as lists or collections. So again, we always seem to have all these other terms, so you might have known them in your previous programming language as lists or collections or arrays. They're all pretty much interchangeable. This one will cover the following learning objective, which is to use abstraction to manage complexity in programs. So as you can see, lists and list operations such as add, remove, and search are common in many programs, and using lists and procedures as abstractions in programming can result in programs that are easy to develop and easier to develop and maintain. So those are some of the things that we're going to hit on today. Again, in MakeCode they have arrays, but then they call them lists. So we're really going to see where things are called different names all the time. So just know that those words are interchangeable. So again, remember for the create task, you have to develop an abstraction that manages the complexity of your program. So we talked about that a lot in the last lesson. We developed functions, which are abstractions as well. Functions or procedures. Lists can help with that too. So they're not required for the create task, but again, as it says back here, it's just another way lists and procedures are, can make your program easier to develop. So lists might be something that can help you out in your program, whatever idea you come up with for the create task. And so you can explain how your abstraction manages the complexity of your program by using a list. Well, so and here are some more instructions from the create task. Your program should draw upon mathematical and logical concepts, numbers, variables, mathematical expressions. We've seen that already. Logical and Boolean operators and expressions. We've done that. Decision statements, iterations, and or collections. There's the one key word we're looking for there. So collections, list, arrays. That's what we're looking for. Those are things that you should try to include. Although collections, lists, arrays aren't exactly required, but they could help you in your program. So we're going to take a look at those today. So again, that's directly from the create task. If you want to know more about procedures and abstraction, again, that was the previous lesson, and we're moving on to lists. Now, lists may not have been something that you have used before, or seen before. So we'll do a couple basic ones here, but they are really pretty easy to use. And now that there's no multiple choice exam, you won't have questions about them. But if you wanted to use one in your create task, it should be pretty easy to use, especially in any block-based language that you're using. So here is the arrays section of the blocks. Again, it's in the advanced section on MakeCode. So you're gonna have to click the little arrow on advanced there to expand and find arrays. So they call the section arrays, but then everything on here has to do with lists. So we'll probably refer to them as lists. Arrays are usually just another way of calling them. But you see, there's a ton of things you can do with a list. So in MakeCode, there are three types of lists. So you have a list that has numbers. You have a text list, which will hold words or strings of characters. And then you can have a list that holds sprites. So notice that it says list and then says an array. So right, an array is just a group of items that are similar types. So that's why there's three different ways to create your list. So you can, again, because we want to put everything of the same type in there. So we have a way to make a list of numbers, strings, and we can make a list of sprites. Notice that once you have your list, all the other things are really to use your list. So you can determine the length of your list. You can get a value at a certain spot at your list. For MakeCode, the items in the list are numbered starting at 0. So these all have an index. So 0, 1, 2 would be the indexes of these three elements. So if I said list get value at 0 and I had made this, it would give me the letter A. So again, in most programming languages, the lists or arrays are 0 based. If you've done one that starts at 1, then just remember MakeCode starts at 0. You can set the value at any position, and we're going to use a loop, which is helpful. And we had the index for index 0, 2. That's a loop that's built into MakeCode that we could use to loop through our list. So we'll see that. You can add a value to the end. You can get a value and then it'll be removed from the list. You can find something in your list. You can get remove the first value. So you got first value, last value. You can insert something at the beginning. So add to the end, insert the beginning. You can insert at a specific spot. You can remove at a certain spot. You can reverse the list, and you can empty it. So lots of options with lists. We are not going to cover all of those things today, but know that there are tons of features available in MakeCode of what you can do with a list that you create. So we're going to jump in and take a look at a program. So again, I'm going to guide you through a project with lists. I'll pause occasionally to make sure you're able to follow along. Feel free to select different colors or pictures. Just don't spend too much time. It's just practice. Once we complete some code together, I'll give you a chance to code on your own. So we're actually going to do one project, and then I'm going to give you a separate project to make yourself as well. So let's jump out here and head over to MakeCode. So I'm going to start a new project. If you aren't there, you want to go to arcade.makecode.com, and you should have this screen. You can see I got lots of other projects here, but we're going to make a new one. I'm going to give your project a meaningful name. So I'm going to call it list demo here. So start a new project, and we got our environment here. So what I am going to do is I'm going to make a list of sprites. So I'm going to make a bunch of sprites actually, and we can do that real quick by putting them into a list. So instead of making sprite after sprite after sprite after sprite after sprite, I can just create one and add it to the list, and then I can keep adding them. We're still going to use functions because functions are good. So we're going to do a function called I'm going to call it create apples. I'm going to make a bunch of apples. So that's my function, and I want to call that function from onStart. So I'm going to make a bunch of apples when my program starts. So to do that, I'm first just going to start by making an apple. So I set my sprite to an apple. Oh, that's a hamburger. That'll make me hungry. Not that an apple doesn't make me hungry. I'm trying to be healthy. So we got our apple on the screen. I'm going to go ahead and just change the kind of food since it's food. So there's my apple on the screen, but I want to make a bunch more. So we could go in and be like, okay, set right 2, and then they get overlapped, and I have to keep putting them, so I'd have to set it again and go get the same picture, and then I'd have sprite 2, and then I'm going to show you how functions and lists can really cut down on the amount of code. So I would probably want to go and I'm going to put a bunch on the screen. So you see right now one jumped over here and one's here. So I probably would want to maybe put them at random spots on my screen. So I could go and say, okay, pick a random, and I like to use my screen width. So then I could duplicate that and put that in over here for my Y value too. And then this, so I need screen height. So we've seen this code before too, kind of done one like this. So that randomly picks where that other one is. I could duplicate that, and the duplicate really helps, but my code's going to get really long. What if I wanted like 15 apples on the screen? So right now I got 2, and every time the program restarts, they randomly show up in a new spot. Okay, that's cool and all, but I want a whole bunch more. So we're going to use a list. So I'm going to get rid of that code. I've got some code here I'm going to put into my list. So I'm going to make a new sprite list. So it's an array of sprites, and they are kind of fluid. So that creates the list to hold sprites. So then I created my sprite here, and I want to add a bunch to the list. So let's go see how we're going to add to the list. So to add to my list, I need to set the value. So I'm going to say list set value at 0, and I need a variable because my sprite is a variable to my sprite. Well, right now that's not very exciting because all I have in my list is one sprite. But if I use a loop, I can get some more sprites. I'm going to go. I told you about this loop before, and I said, oh yeah, this is going to be real helpful now. So if I use for index from 0 to 4, and so instead of set value, oh look at that, I already have a bunch. So and I didn't even change that. That's interesting. So I need to really use my because it happened, but because it did create the loop created 4 sprites, but I've also put them into the list. Now we're going to see why putting them into the list is helpful because I did not put them in the list, and they show up on the screen still. Remember 0 to 4 is 5 actual, so we have 5 apples on the screen. But by putting them into a list, I'm going to show you what we can do with them. So that doesn't really change anything visually right now, but I have them on a list and I can access them all. So I created my apples, and they're all random spots on the screen. I'm going to go ahead and make like 16 of them. So I'm going to go 51. That would have been a lot. So I didn't want to totally fill my screen. So now we got 16 apples on the screen. Well, I actually want them to just all move all over the screen while the program is going on. So I'm done with my onStart. I'm done with that create apples. So hopefully you got that code. You can always pause if you need to. So we're going to do a game update, and we're going to make another function. And oh no, I don't want to call create apples. I want to make a new function. So make a function, and I'm going to call this one move apples. So I'm going to make a move. So move apples is what I want to happen. Now let's make it crazy. Watch out. The stuff's going to move really fast. So I'm going to call move apples when the game update. Well, there's nothing to move apples, right? So, but I can go through my list of apples and make them all move every time the game updates. buckets. So again, to go through my list, I'm going to use a loop. So in my list, you could put in the length of your list right here. But I'm just going to go ahead and type in 15, or you could use variable. But remember that the length of the list would be 16, and we need 15 here. But you could add in some mathematical stuff if you want to go ahead and put length -1 in there instead. But I'm going to go through every item in my list, and I am actually, so I need to I'm going to move my sprites. So I'm going to duplicate this block, and I'm going to say set my sprites. Okay, now you might see it. Notice what happened. One apple's moving all over the screen because I said set my sprites. Well, my sprite is the last sprite you make, but I want all of them to move. So to do that, instead of saying my sprite, I can go into my list and get each value out of my list and have it move. So again, this is going to do the same thing because I only said get value at 0. So that's still the first item. Now I've got the first item I put in my list and it's moving around. I want all of them to move. Now this is going to get real crazy. We're going to maybe I should pause it, but I'll let you see it go crazy for a second. We need the variable index. So we're going to pop index in, and there they go. They're all going like crazy. Like I said, it's a little crazy. We need a pause. Oh yeah, put a pause in there. Then it won't quite get so crazy. So I think that's where I want my pause. Yeah, pretty much any place to pause will help slow it down a little bit. You can change that pause, but will they remove a little too fast for me? So notice that one big block there with all of our pick random, it's a little crazy. Kind of nifty here that we were able to have them all move at once. So they all move around the screen. Now I said that I would introduce another topic today too, and that is a parameter on a function. So I noticed, and you can see here, this big long block here. I use it here, it's really long, and I used it over here too. So I just have a different, the only difference here is here I said my sprite, and over here I said list get value at. I really could almost make them the same, but we're gonna use another function to be able to basically move any sprite we want to a random position. So I'm gonna introduce a function with a parameter. So go to the functions, and we're gonna make a function. I'm gonna call it move random, and then right here you can add parameters. The parameter lets you send something that then you can manipulate in your. So if I add a sprite as a parameter, and you can call it something else. So like, since we already have my sprite, I'll probably just call it we can call it S even. Let's just call it just sprite. Okay, we'll call it sprite. There we go. So no, we shouldn't just call it. Let's call it S sprite. Real ingenious here. So move random S sprite and say done. And so now you've got a parameter. And so what I can do with this move random function is, so instead of having these two big long lines that make my program really hard to read right now, what I'm going to do is I'm going to pop one of them into here. So that's going to stay over there. I'm going to pop this into here. And so instead of my sprite, I'm going to change this to my parameter S sprite, which I just have to drag down there like that. So now if I call move random with a sprite, trying to get rid of that back there, don't need it anymore. Oh, I will. Sorry. Move random with a sprite as a parameter, then it'll still do the same thing. So remember, I did it here and I did it here. So that was supposed to be inside my list, wasn't it? So function calls. I'm going to call move random right there. Already says my sprite. So it's adding them all to the list, and the other part's still working the same too because I haven't changed anything yet. But this should move it to a random starting point. But then I'm also going to replace this big long one. Don't forget to put that pause back there. I'll get a little crazy again. I can replace it with a call to the function, and then instead of my sprite, I need that whole block we had right here, which was this. I'm gonna pop that in there. I don't need that block anymore. That's what I cleaned up. So call move random with this sprite, the sprite from my list. Oh, I gotta change this to. Oh, did I not sprite? I changed that sprite. Didn't do that earlier. Oh, I didn't do that earlier over here either. Let's call that sprite. Okay. There we go. So this one big line or block of code is able to be put in this function. I can clearly know that it randomly moves that sprite around the screen, but I don't have to worry about it kind of cluttering up my other code. So I know, oh yeah, call move that sprite randomly. The sprite from my list at value index. Call it move it. Call it move it pause. So we're able to move a bunch of things all at once, and by just adding them to a list. So again, using functions, which help keep the code nice and neat and a lot more organized. So the two on bits that are built in, I just call functions on my own, and then it's a lot easier and a lot cleaner in the code here. I can clearly see what's happening, and then we use the parameter to even more generalize our code to help with how to help with keeping our code clean and not going all over your screen stuff. All right, we're gonna go back to the slides. It's gonna be your turn to try it out. So here's what I have for you to try this time. So I want you to start a new project. Use functions when possible in the project, just like I did on the last one. In the on start, I want you to create 2 sprites on each side of the screen to have a conversation. Create a text list of things the sprites would say. So just keep it short for now, but put 3 things in a text list that you would want the sprites to say to each other. In the on game update, randomly select one of the items from the list for each sprite to say. You'll want to use the pause again, but you're gonna have an on game update kind of have the sprites talk to each other. So you'll have them randomly pick one of the words you put in your list for each sprite to say. We've used the sprite say block before, it's in the sprite. And then a challenge, because it's tricky, not required. Challenge is to use a function with a parameter to reduce any repeating code that you see. If you, when making this, if you see any codes, or just like the example I just showed, I got to the end and I'm like, wait, these lines are very similar and really big. It'd be better if I put them into a function, called it with a parameter, and then I could just call that anytime I wanted to make that happen. So keep that in mind. That's a tricky one. I'm gonna come back after 3 minutes and show you how to do this one. It's not quite as long as the one I just made. So just make 2 sprites real quick to talk to each other, and then make a list of things you want them to say, and then in the on game update, I'll pick one of those randomly for the next. Give you 3 minutes, and I'll come back and show you how I did it. up. If you didn't finish, again, you can always pause, but I'm going to jump back in and show you how I do this and with some functions and then that challenge at the end of the parameter too. So let's head back over to MakeCode. So I'm going to start a new one like I asked you to do. So new project and list demo 2. So let's take a look. So for my instructions, we're doing some things in the on start and in the on game update. So I'm going to go ahead and pop those both in there. So on start, I'm going to create 2 sprites to talk to each other. Well, I'm probably going to put that into. So I'm going to call that function create sprite. Since I'm making a couple, it might get a little lengthy. So my sprites, I'm going to set, I want them to talk to each other. So I'm going to pick on 2 that are facing each other. So I'm going to keep with my duck. I really like rubber ducky. And then I'll have to set it as a little kitchen here in a second. We'll go ahead and get sprite number 2. And I'm going to set that to one of these others down here facing him. I haven't used this like how to do that. So they'll be facing each other, but right now they probably start out on top of each other. It would show up over there. Oh, it's not showing up because I haven't called it yet. So I'm going to go to functions and call create sprite. And in my start, and I have 2 sprites on top of each other. So I want to go to set my sprite position in there and set my sprite position. Nope, I don't really want them up in the corner. Change that to my sprite 2. And let's see, set the position of this one. My duck on the left. So I'm going to go 20 and move it down on the screen, maybe like 80. No, not quite that far. 75. Okay. And then the cat or whatever it is, I'm going to move it to further over to the right. So I'm going to go 80. Oh, I'll go 100, 120. Yeah. And same spot. So 70. This one I need to move in a little bit. I'm going to go 30. Or what he says is going to go off screen. So I got 2 sprites that are like facing each other so that they're ready to go there to have a conversation. So hopefully you got that part done. And then I need to make a list of things for them to say. So again, I'm going to use a function and I'm going to call it create. Let me come up something better there if you want. And I'm going to make my list in there. So I'm going to make a text list this time. So there's my function create list. And I'm going to have it say things. So hello, goodbye, and make, oh, yeah, goodbye. And doing all right. I have a question. Okay. So I made a list real quick, 3 things in the list. So I probably want that to happen again, as I said, in our on start. Now nothing's really going to show up. I just have sprites right now and I made a list of words. So as I said in the on game update, we're going to have the sprites talk to each other. So to start out with, I just went ahead and had the sprites talk. So to do that, oh, here's where, so you could have just went ahead and gone in here and put in, where's my say? There it is, my sprite say. You could have gone in here and said, okay, my sprite say. Now how do you get a random item from a list? So we go to our list and we want to get a value from our list. So that's what I need in here. And I'm going to change that to text list. So right now, on game update, my sprite says the value is 0. Well, I want it to say a random value. So I need random. So I'm going to pick random. There are only 3 items in my list. So I only pick 0, 1, or 2. And right now, it just quickly says them all. Don't forget to pause is helpful. So throw a pause in there so he doesn't just say them all quickly like that. So right now, I got it to say them, one sprite to say them every second. He picks a random value and it says, okay. You can also have it say it just for a short amount of time. So it kind of takes a break between words. So there's some tips there. So now, in order to get the next sprite to say something, it would kind of be the exact same code, unless I was using a different list, which that you can make another list and you could, have different words that they say, but you could still use a parameter for that. So what I'm going to do is I'm going to make a function right now. So I'm going to make a function and I'm going to call it, let's see, sprite talk. And I'm going to put that code that I just put in there into my function. So I'm going to pop that in over here. And so in on game update, I'm going to call that. Well, I didn't do much code yet, right? I forgot. I wanted a parameter. I wanted to send a parameter to sprite talk as to which sprite was supposed to talk. If you forget, you can right click on your function and edit the function. So I wanted a sprite. I'm going to say sprite again and add that parameter. So it adds a parameter. So instead of my sprite, I'm going to put sprite right there. Now I need to call it with my sprite, which you see is already happening. So I can trash that. And you see now that I've got my first sprite talking. So then I can call it again though, call sprite talk with my sprite 2. Oh, not list my sprite 2. And now when we update over here, we should have both sprites talking. Now that was with the parameter. Again, if you just put code in the on game update, that's okay. But we were trying to do some more things here with parameters and functions and really using all the features that we can. So, but the idea was for a list, I can get a random value from 0 to 2 because my list has 3 items, 0, 1, 2. Remember that there's 0 base in MakeCode. And so I put the name of my list, get value at, and then I can have, so then my sprite randomly says that. So you see they're having a little conversation right now. You could even put conversation, and have it kind of change up or something into another function, but that pretty much makes it easier because you call sprite talk. You can throw a pause in here. I couldn't really, you can mess around with that some more, but couldn't really get it to kind of pause and take turn, but you can probably mess with that more to get them to take turn talking. So that was the idea behind that program. If you didn't use functions or lists, or hopefully use the list, if you didn't use functions and parameters, that's okay, but just keep that in mind that really helps keep the size of your code down. And so for this one, I was able to kind of keep it all on one screen here. As you move towards actually getting like a screenshot for the create task, you might have to take multiple and move your blocks around and kind of organize them. I would organize all your function calls together like this again, and then your functions otherwise in separate places. So kind of keeps your code organized of what's happening in this section. And then if you need to know what's happening in create sprites, you go find that function, you can see what's happening. So that's the idea behind using functions and managing your complexity. So that is it for lists. Hopefully you're able to test that out. We'll head back over here to the slides and wrap it up for this lesson. So today we learned how to include lists or arrays or collections in our project. This can be a part of the create task and help manage complexity because we're able to randomly select those words there, which helps keep it so it was easier to have a conversation. And when we had the apples or tomatoes, we were able to make a bunch of things move all at once by just using a list. So your program should draw upon these concepts, including collections is one in there. So it's an option that you can use. This is the final lesson about using MakeCode. So if you want to see any others, again, there's 5 in the series. So we did sequence, selection, iteration, and now we've done functions and lists. So hopefully you've been able to learn a little bit about MakeCode, but really it's to have those concepts in a new environment in case you can't use the environment you learned. And then there will be 3 more CSP lessons. Be sure to tune into those. They'll include student samples and directions on how to submit, explore, and create tasks. So those lessons will be posted soon as well. So if you need help with that, go ahead and check out those lessons. But this is it for the MakeCode environment. Again, if you know somebody who needs a device or internet access, please go to cd.org/tech and fill out the form and take help to a student that you know, or if you're a teacher to a student. So thanks for watching, and that's it for MakeCode. Hello, and welcome to another lesson for AP Computer Science Principles. I'm Mrs. Julia Lano. I teach at Hamilton Southeastern High School in Fishers, Indiana. If you watch my other videos, you probably saw some of the things. I've been teaching AP Computer Science Principles since the course started, and I've also taught AP Computer Science A for almost 1 year. So really love computer science and really excited to show you some new things in MakeCode today. So let's jump on in. So in today's lesson, we're talking about procedural abstraction in a new programming environment. And that's MakeCode, which I've shown you before. So what is procedural abstraction? Let's talk about what we're going to cover today. And you may not have heard that word from your teacher. So let's talk about what that means. And this is a really, really important topic for the create task. So seeing it in another language would be good for anyone to watch. So we'll focus on functions in programming. Functions are also known as procedures or methods. So that may be what you've heard in your programming language. So that procedural abstraction means we're going to be using a function or procedure or method. So that is found in Learning Objective 221, which is part of the create task, which is to develop an abstraction when writing a program or creating other computational artifacts. So, and as you know, probably know, response 2D requires you to write about the abstraction you develop. So that is going to be the biggest part of today's lesson is we're going to learn how to develop our own abstractions in the MakeCode environment. We've seen other abstractions in MakeCode, but it's important that you know how to make your own because that's what's required for the create task. So if you don't know, the process of developing an abstraction involves removing detail and generalizing functionality, which makes your programs a whole lot easier to read. And an abstraction extracts common features from specific specific examples in order to generalize those concepts. And you can also do it with input parameters that allow software reuse. So we're going to see that as well. Those are not required for the create, but we'll see how we can do parameters with a programming environment. If you've used them before, you may want to use them again. So that's the first part that we're going to see today. This topic is also from Learning Objective 222, which is using multiple levels of abstraction to write programs. So while we're not required to, really have this for the create task, it's still something you should know that you should be aware of, is, how we can do that to solve the problem you want to do for your create task. So that's another item that you will see today. And this lesson will also cover another learning objective in the create task, which is learning objective 531, use abstraction to manage complexity in programs. So I kind of hinted at that before. And so from that learning objective, here's some essential knowledge statements, or here's what you want to know. So procedures are reusable programming instructions. A procedure is a named grouping of programming instructions. So we're going to see that in MakeCode today. We're going to make a function. So and we're going to put a group of programming instructions, which could also be called an algorithm. And that's what else you need for the create task. So procedures reduce the complexity of writing and maintaining programs. We can just call them when we need. And using lists and procedures as abstractions in programming can result in programs that are easier to develop and maintain. Tomorrow, or actually the next lesson right after this, is about using lists. So we'll see that as well. But today we're focusing on procedures. So it helps you develop, maintain, and organize your code. And so this is a key part of that create performance task that I believe most of you still need to do. So lots of things there, lots of topics. So hopefully, again, this lesson is meant to show you how to do this in MakeCode. Hopefully you've done some procedural abstraction in another programming language. If you're not familiar with MakeCode, you'll want to watch the previous lessons, which introduce you to using sequence selection and iteration. And so that's the previous 3 lessons that are already posted. But today we're moving on to making functions in MakeCode. You can really find these details in the create directions or requirements. So directly from the requirements from the color board, you are required to develop an abstraction that manages the complexity of your program. So that's part of the create task instruction. And the program must demonstrate development and use of abstractions to manage complexity of your program. So procedures, abstractions provided by the programming language API. So we've seen abstractions provided by the programming language, which you have to create your own. Because written response 2D capture paste a program code segment that contains an abstraction you develop individually on your own. This abstraction must integrate mathematical and logical concepts. Explain how your abstraction helped manage the complexity of your program. That's written response 2D. So very, very important topic we're covering today. And we will still go back and talk about mathematical and logical concepts as well to make sure you can see how those can be put into your function. So key topics today to help with that response 2D part of the create task. So what you need to know, this is what we're going to take a look at in MakeCode today. So the function section of the blocks is in the advanced section. And again, I'm going to show you this in the MakeCode environment in just a moment. But this is a screenshot. So we've used all this section. So you will have to expand advanced to get to functions. When you do that, you should see this, which allows you to click the button here and make a function. Once you make a function, then that function definition block is added over in the programming environment. And then a block to call that function is added to the function section. So if you have multiple functions, you'll see them all here. And as soon as you make it, it creates the block so that you can define it right over in the code. So we're going to take a look at that today, create some functions, and we're going to use some other blocks as well. So there's some other blocks within MakeCode that might be useful for you. Under the game section, there's a prompt and dialogue section. So you can splash a message on the screen, or you can put it text box on the screen. You can ask for items. So that might be something you want to use, and you can put those into variables. We're going to deal with overlaps of sprites. So that is found in the sprite section, and we're going to use some of this today. And then there's also an info section, which includes a score. Now, I would prefer to make a variable score myself, but it wasn't showing up on the screen the way I wanted to. So this score automatically shows up on the screen for you. So I'll show you a way to make sure that you adjust the score and do the mathematical concepts you need to. So we'll be using this score kind of built-in variable today as well. So let's take a look at these other new blocks in MakeCode just in case you want to use something like those. So it's now time to head over and we're going to try out some new blocks as I just showed you in MakeCode. So I'm going to guide you through the beginning of a project today with functions. I'll pause occasionally to make sure you're able to follow along, and we're going to set up a whole new project. Feel free to select different colors or pictures. Just don't spend too much time as this is just practice. Once we complete some code together, I'll give you a chance to code on your own. So to create some functions yourself to add to the project we're going to make. And then you should end up with a quick little project that you might want to share today. So that's the plan as we head over to the MakeCode environment. So let me jump out of my slideshow and over to MakeCode. If you have a project up, you'll want to go back to home as I just did and click new project. As you can see, I got quite a few I've been practicing. Hopefully you have too. So here I'm just going to call mine functions and demo. So we'll take a look at this. So if you need to make a new project, just as I did, and we'll start out nice and blank screen here on the MakeCode environment. So we're going to start out right away by creating a function. So again, if you haven't done so, you'll want to expand this section right here so that you can find the functions in the MakeCode environment. We're going to use some other new blocks, but I'll show you those when we get to them. But for now, functions is our key section. So I'm going to start out by calling a function to kind of set up my script. So I'm going to make a function and I'm going to call it set scene. And you can name them differently. Usually we want to name our functions like a verb like that, and then we use that camel casing. Notice the outer parameter. We're going to get to that later. But for now, we just want this function set scene, and we say done. Pops it over into the coding environment so we can define it. And then if you go to function section here, you can see that we already have a call. In order to see how my code runs as it goes, I'm going to go ahead and put call scene, set scene in the on start method. So by putting that in there, then it's all set. Whatever I add to set scene will automatically happen on the start of the game over here. So then I don't have to I know what's happening in my code. I will see what's happening. So in order to set the scene, I am going to I'm going to set my background. So I'm going to go to scene and I'm going to set my background to a color. So I'm just going to pick a color again. You can pick whatever color you want. So I'm going to set the background and I'm going to add some sprites. So I'm going to go to the sprite section, set my sprite. I'm going to make a duck. I really like the rubber duckies. So we're going to stick with the duck here. Again, you can pick whatever you want, and I'm going to leave that duck as the player. I don't really want the duck there. I'm going to move the duck a little higher right now. So I'm going to set his position while I'm doing this as well. So not up at 0, 0 in the corner. Let's go down a little bit and over. So I'm going to go 20 and then 50 where that is. Oh, no, not quite 50. I think I'll go 30. All right. So just putting him a little further down the screen. And again, as you enter code or move or set anything, your window over here should reset, or you can always press the play button to make sure you got what you want. So there's my duck. I'm also going to add a fish, I think. So we'll go to sprites, and yep, I want to set my sprite 2. So to a fish. So I'm going to go pick out one of the fish down here, and I'm going to make the fish the enemy. This is going to help later on with one of those new blocks we saw. And I'm going to put the fish a little further down on the screen. I didn't show this before, but you can right click on blocks and duplicate them. You can also add comments or delete or work with it that way. So I'm going to duplicate this one because I want to set my sprite 2, and then I'm going to move him further down the screen. I kind of liked where he was that way, so I'm going to move him to like 75 and then down to maybe 150. Oh, that's too far. Let's go 80. Looks great. So then we should see, yep, maybe I want a little further down on the screen. Let's go 90. Yeah. So then we have a duck, we have fish, and we've kind of set the scene for our 2 things. I'm going to go ahead and add some instructions this time too. So this is something else you can add to your program. And we find that in the game section. If we scroll down here, you can show long text at the bottom of the screen. So I'm going to go ahead and just leave that there for now. So obviously this is kind of nice too because your program, the rest of it won't run until you hit, as you see here, the A, and then it kind of does your program. So it's a good way to have your program kind of wait until somebody's ready to use it. And I'll put some instructions in there later, but for now, just know that we kind of set our scene. We've set everything up. And notice that the on start is really nice and clean and shows what is that it's just clearly all done to set this, nothing else is happening. So I'm going to make another function called set variables. We're going to use some variables in the program, and so I want to just go ahead and have them all in one place. The idea behind making all these different functions is then you know when something's wrong, where to find it, and it's that managing the complexity. So I know if something's not set up right, I can go here to adjust it, or I know when I want to update something about my scene, I go here to adjust it. So we're going to make another one called set variables, and this really keeps that on start function really clean. And again, we're going to go ahead and put my call in there. So I'm going to call set variables and put that into my on start. So the on start, nice clean, tells me what's happening when the program starts. Back up here to my function set variables. I am going to have a score this time, so I want to set score to 0 to start with. So pull that in again. That's in the info section. We are using that, and if you go ahead and click on A, you'll see the score shows up on the screen, which is the reason that we're using the score from the info section. You could create your own variable, but then it was difficult to put it on the screen in the way I wanted. So we're using that built-in score. So once you click the A, you should see your score there. And then I am going to make the fish move, and to do that, I'm going to need a variable. I'm going to make it. I did this in another lesson, so I'm going to make him move back and forth. So I'm going to make another variable called fish change. So it's going to be used to change the fish position. So I actually want to set that to 5 to begin with. So I got 2 variables right now, but it's really nice to have that. Again, if I want to add a variable later, I set them all there. I know that's where I set all their initial values. I know that's what their initial values are and where to find that. So I don't have to search for where I set the value of my variables. So it keeps that code nice and neat and clean, and what's happening at the start of my game or program. All right, I'm going to move on to put some code in the on game update. So now I want some stuff to happen while the game, throughout the game. So in here, and you're going to get to add to this game here in a little bit. And here I'm going to go ahead and make the fish move. So I'm going to make another function, and I'm going to call it move fish. So I'm going to pull that in. I like to keep my, doesn't really matter where you move things, but I'm trying to keep it all down here now. So move fish, and I'm going to put that call. So now that I've made it, I can call it. I'm going to call it every time the game updates. Now I'm not going to really see much over here because I put that message on the screen, so nothing will really happen unless I hit the A. So for move fish, we did this one before. So what I'm going to do is I'm going to have the fish just bounce back and forth across the screen. So to do that, I'm using my variable, and I got to see if it gets to the edge. So I'm going to use an if statement. So pull in the if. Oh, I'm going to need an if else. And in the if statement, I am going to see if the position of my fish, which is again my sprite 2. So variable. Oh no, I need sprites. I need where he is. So I need to pull in if x position of my sprite 2 is greater than the screen width. I gotta pull that from the scene. So if the sprite is greater than, because what I'm going to do is I'm going to do a change. And again, I did this code in a previous lesson. I'm just using it again. So what I'm going to do is change my fish by my fish change variable. So I started out using 5. So if I change my fish's x position by 5, then it's going to go greater than the screen width. So if I show it, click A over here, yeah, my fish just went off the screen. So what I need to do is I need to update that fish change variable. So I'm going to go in here and I'm going to say set fish change to -5 at this point. And again, then I need to see if it goes off the other side of the screen. So I have to do an else if here. And I'm going to pull in another. You can right click and duplicate block. Oh yeah, I didn't do that. It's much easier. So now I need to see if it's less than. So click that and get less than, and then don't need that in there. So if it's less than 0, then I want to set fish change back to positive, so it doesn't go off the screen. So I'm going to duplicate that block. Yeah, pop it right in there and change it back to positive. So I should, once I hit my A here, it's going to have my fish bouncing back and forth across the screen. So let's see. Oh, beautiful. So again, we did that before, but we're going to use that in this program at the end. So I wanted to go ahead and show you how you can use a function and say, okay, this is going to move the fish. And I use my variable that I set in my set variable, so I know what my initial value are. So it's a little crazy watching them back and forth across the screen. So I'm going to stop that. And I got one more that I'm going to do before I let you try this out yourself. So I'm going to add in a projectile. That's more fun, right? So I'm going to do on down button press, and I'm going to do a function again. I'm going to make a function that is, I'm going to throw apples. Throw apple. That's what this function is going to be. I'm going to throw an apple. So I'm going to pull that down here so I can see a little better. And again, I'm going to do that when the down button is pressed. So I'm going to call throw apple here. And this block that I'm going to put in here is going to get real long. So I'm going to go like this so we can see it. And I'm going to go into the sprites here and set my projectile. So to throw from my sprites, yeah, that all looks good. I just need to set it to an apple. It's apple or tomato. I'm not sure what it's. I'm going to say apple. And so again, nothing really happened yet because I've got this little message right there, which we'll fill in later. Or you can fill it in later, but I just want to show you how you can kind of keep your program started. So at this point, when I press the down button, my duck should throw apples. All right, I'm going to click A and down button. Oh, I'm getting some apples. So as you can see, we're going to add some other things to this little game here, and I'm going to have you do some of that on your own. So I'm going to give you a chance to do that, and then I'll come back and show you some other features, including how to add a parameter to your function. So let's go back out to the slides. And so I got 2 functions here that I want you to make. So I'm going to go to the slides here. So I want you to add to what we're already working on, and I want you to create a function to move the duck using an if statement and the left and right arrow keys. And then you're going to call that function from the on game update. So same place we called that we have move fish. You're going to call a function to move the duck. You're going to use the arrow keys to move the duck. Also create a function to update the score when the tomato hits the fish, tomato apple, whatever, when it hits the fish, and call that function from the overlap of it. So maybe forgot to show that. Let's show you that. You're going to need this other event that we haven't seen yet. I'm going to scroll down here to this one. I'm going to pull it in. Go ahead and pull this one in for you to show you what you're doing. My screen is getting full. So on sprite assigned player overlaps. So really we want sprite projectile overlaps enemy because we made our fish an enemy and we have our projectile, which is the apple. So you'll need to use this block in the things I want you to try here. So I'm going to give you 3 minutes. You may need to pause the video if you run out of time to get this done. But try these 2 out. I forgot parameters is the next one. I'm going to show you how to do parameters next. So for now, we're just going to create 2 functions. And then one's going to go in the on game update, and the other call is going to go in the on overlaps event. So 3 minutes, try it out, and then we'll come back and take a look. able to finish, that's okay. You want to pause the video if you don't want to see me do these things. You just pause it and then come back on and see how I'm going to show you how to kind of finish up this quick little game. So let me get out of the PowerPoint and head back over to MakeCode. So I meant to show you this one earlier, sorry. And you can quickly see, I'm going to have the sprites have an effect. So when they do overlap, we want my sprite 2, and I can make it like bubble or something. So I'll go ahead and show you kind of how that overlap event works. So if we run and press the A, so now if I use my down arrow and I hit the fish, I'm not a good gamer. Oh, we see some bubbles happen. So I forgot that I want to change that only to do it for a few seconds, because then you can really tell when you hit it. So again, throw in my tomatoes at the fish or apples or whatever they are, and so then you can tell you hit it with bubbles. That's pretty nifty. You can add effects like that. So there's that. But I asked you to make it'd be nice if I could move my duck. So that's one of the things I asked you to make. So to do that, we make a new function. So function, and we make a new one called move duck. And notice that I asked you to do an if else in here. So we're still trying to use that logic within our functions. So we're going to have the duck move if buttons are pressed. So if the left button is pressed, then I want to change my sprite by -5, and then else if. So we got to do that, and then okay, put that in here, change that to right. So this was what, again, we've done this kind of code before. The key was making the function, and then I put in if the left is pressed, go negative. If right is pressed, go positive. So I want to do that anytime the game is going. So that goes into the on game update. So I need to call move duck. All right, that's more code. I should test it out. So I'm gonna play and press A. So now, as you can see on the screen, I'm using the arrows on my keyboard, so I can move my duck, and then I can throw apples, tomatoes, whatever it is I got here. So using my arrow keys, I can take care of that. Okay, now let's add the other function, which was to update the score. So we've got this showing that we're hitting the fish, and so we'd like to update the score. So we're gonna make another function called update score, and pull that down here so I can see what else is going on. And so I'm gonna go ahead and put it down here where we see we're gonna be next to it. So I'm gonna go ahead and put call update score over here when I hit the fish. So to update the score, this is important. There's some built-in features of MakeCode, but it's best remember that you need to include math and logic. So to include math, I am going to do set score, and I'm going to set the score, and I'm going to use math and say I want it to be whatever the previous score was +1. So that is a way to include mathematical operations, even though we're using this built-in score. So set the score to whatever it was previously +1, and so it'll update it to that, and that updates the score. And again, we call that right here when we have an overlap, and so we'll test it out. So we're gonna run the program, press the A to get it started, and use your arrows and the down button, and I missed, of course. And you see it kind of hits the overlap, and we get lots of points, but you can see that that does change the score when you hit fish. So that's another feature. I'm gonna show you one more feature that I'm gonna add. I didn't have to do it earlier, I'm gonna show you one more, and then that'll be it for this lesson. So say you want the fish to speed up. So maybe when you get to a certain score, you want fish to speed up. So we could add in an if statement into this block and see if the score is greater than a certain amount. So we'll pop score in there. So if it's greater than 20, let's say, then I need to change something. So right now, I want my fish to move faster. So let's go over here to see when my fish moves right now. I change it by 5 and -5. Well, I have to do that to make it go back and forth, negative, positive. But I need to be able to change this. So I need to be able to change that number. So that's kind of tricky because otherwise it'll get a little trickier there. So what I need is another variable. So again, this adds more math and logic. So I'm just going to change my fish's direction. So this is just fish change variable. It's just going to change the direction. But then if I add in another variable, I can use it to multiply by fish change, and then I can get the speed to change. So how fast the fish is moving. So I'm going to make another variable, and I'm going to call it fish speed. And remember that I set up all my variables in one place. So I'm going to put that block over here, find where that is. So call set variables. Oh yeah. So I'm going to set the speed. So initially my speed was 5. Oh, I need to change my fish change to 1. So right there in my set variables function, I found everything I need to do to reset this game a little bit so that I use speed. Notice that I added a new thing. This is again things you can do on your create task. Oh, I think I want to change the speed. That's this is part of the incremental development process. So now I need to multiply by that. So fish change times fish speed. So now if I set it to 5, it's still doing the same thing. Nothing's going to change. I just had to get it so that I could change direction, but then this multiplies it by 1 or -1 to move it positive or negative. 5 more not mounts. So over here in my update score, wherever it went, there's update score. If the score is greater than 15, I am going to change the fish speed. So I'm going to set fish speed to, let's say 8. So let's test this out. Last part of the program, and we're going to run. I never got my directions in here, but no, you can just type test in and it shows up there for direction. And so I got my arrow keys. I need to hit my fish so I can get up to 15 and see what happens. So I'm no good at games. If you can't tell, I probably should practice that. Oh, there he goes. Now he's going faster. We got 16 as our score, and the fish is moving faster. So you can see some new features or new things you can try in your programs. So maybe add a little bit more there. Remember, you can always pause, slow it down, check out. And there's a lot of code going on now. But the key is when we added these functions is that I can clearly go to the main things in my program and know that when I start, I set the scene, I set my variables. Every time the game updates, the fish moves and you can move the duck. And then when the down arrow, you throw the apple. And then you can clearly see your other on update here where we call update score. So you can kind of keep your function calls all together. And then if you need to, if it gets a little crazy, you can plop your functions on top of each other, kind of pile them up, and then you can find what you need if you're trying to update code. So it may get a little crazy with a lot of blocks, but just kind of pile them up and keep your calls all in one place. And that'll help organize your code. So hopefully you were able to see a little bit more. I'm going to head back over to the slides here. A little bit more about MakeCode today. So I introduced some other new blocks in addition to how to make functions to organize and manage your code. So we learned how to include those functions in our projects. This is an important part of the create task. So remember, written response 2D, capture and paste a program code segment that contains an abstraction you develop individually on your own. This abstraction must integrate mathematical and logical concepts. Explain how your abstraction help manage the complexity of your program. I gave some examples of that today. Again, you need to make your own create project, come up with your own ideas, but there's some, making sure that you have the idea of how you're going to create an abstraction. So for example, one that we had in there was the update score. It included mathematical and logical concepts as well. And so keep that in mind as you're planning for your create task and the project that you're going to create. And one more lesson on MakeCode. We're going to learn about data abstractions or lists in the MakeCode programming environment. So that's going to be really fun. We're going to make up things using the list. So make sure you stay tuned for that. But that's pretty much it for today's lesson. So remember, if you know somebody who needs a device or internet access, please contact the College Board at cd.org/tech. So if you have a friend or if you're a teacher and you know students who need this, please contact them ASAP. And that's it. Thanks for watching. Hello and welcome to another AP Computer Science Principles lesson. I'm Mrs. Julia Lano from Hamilton Southeastern High School in Fishers, Indiana. Just another little fun fact, if you didn't notice, I got a little run up there behind me. I am also the girls track coach at my high school, so it's really fun teaching computer science, but also being a coach and hanging out with students that way. So hopefully you've enjoyed the first couple lessons. Today we're going to move on to loops or iteration. So again, we are using the MakeCode environment, which should work on any device. I'll pull that up a bit later and make sure you know what to head there. But in today's lesson, the topics we'll cover, which again you have probably done in your own class, but we'll cover today a little bit too. Loops are also known as iteration. So again, we're hitting that learning objective 411, which is develop an algorithm for implementation in a program. So iteration is a repetition of part of an algorithm algorithm until a condition is met or for a specified number of times. So we're going to try to take a look at both types today. And remember that every algorithm can be constructed using only sequencing, selection, and iteration. So when you're thinking about writing your algorithm for your create task, we will have covered all three of those now because sequencing and selection were previously covered in the last two ones I did. So, and remember for the create, we'll also still be talking about learning objective 551, which is very much involved in the create. So down here in the create, iteration is part of your program should draw upon. So all these things, talk about a lot of those things. We're going to hit some of them again, but iteration is another one that you should not exactly required, but you should. It's very helpful to have things that. So we're going to take a look at for loops and while loops today. So there's various types of loops. Again, in the last lesson we kind of saw a forever, and then on game update actually is a loop that happens over and over. So again, the key to what makes it a loop is that so anything that has your code key, and so it's very helpful to use that a lot of time in programming your app you're going to use for create. So what you need to know, what we're going to take a look at in MakeCode today. So this section loops. So again, we jumped into that section earlier. We've used the forever in the last lesson, but today we're going to use the pause, especially in just this environment you might need it. And then there's a repeat. We'll probably stick to the while and the for. So hopefully you've seen those before, but if you want to use repeat, that's also good too. The repeat and the for loop are kind of similar, but not exactly. This one repeat 4 times would mean it would happen 4 times. This for loop right now is indexed from 0 to 4. So 0, 1, 2, 3, 4 would actually happen 5 times. So then they're similar in meaning that they're loops that you would have happen a set number of times. So keep that in mind for those. The while loop will continue while a condition is met, and the forever goes on forever. Keep that in mind if you're using one of those. So hopefully these are familiar. We'll be also incorporating many of the blocks that we saw from the last 2 lessons. So still getting used to that MakeCode environment. So we're going to move into some guided practice. So I will once again, I'm going to guide you through a quick project with loops. So just one this time. I'll pause occasionally. I'll try to go slow to make sure you're able to follow along. Again, feel free to select different colors or pictures. Just don't spend too much time on that. Otherwise, again, once we complete some code together, I'll give you a chance to code on your own. So I'm going to give you a task again, so you can try out, putting a loop into your code yourself. So the project with loops today, we'll take a look at it. We'll be using that index, the index in that for loop. So we're going to be using a variable. That's helpful too. Help involve a little bit of variable. So I'm going to jump out of the slides here and over to MakeCode. So if you haven't joined us already, this is to get to the screen again. It's arcade.makecode.com, and you just want to click new project, and you should get this screen. Again, you can do this on your phone or tablet, using any device you want. I mean, and you can use Chrome or Safari or whatever you want to use to access arcade.makecode.com. So once you click project, you will get to this screen, and today we're going to put a sprite in, of course. Need a sprite start. So jump up to sprites, set my sprite. Again, to do that, you want to click right here on the gray and pick out a sprite to use. I am going to use fish this time. I think somewhere I saw it. You see, there's a lot of options, so don't get too caught up. I found a fish earlier. Maybe I won't. Oh, there he is. That looks good. I'm going to use that as my sprite today. So again, as soon as you do that, he should come up on the middle of the screen. And now we're going to work with a loop. Now, as I said before, the on game update is a loop itself. But in order to include some of these other loops, you notice that they have that dip in their block. So in order to include them, you have to put them into some other event or something else. So an on game update is happening over and over again, but then we can have it do a loop inside there that happens multiple times as well. So actually, we're kind of creating a forever loop, but we're going to take a look at this for loop here and see what we can use to do it. What we can do with it. So I'm going to use this to make the fish move around the screen. So I talked about the random before on my last lesson, and I didn't use it. So maybe we should use random this time. So I'm going to go get a where we're going to set the sprites. I'm going to go into sprites, and we're going to set my sprite to a specific spot. So right now I set it to 0, 0. Oh, he just went off the screen up there. You see him in the corner. So yeah, 0, 0, stop left. Good to know. So I am going to set my sprite to pick a random spot. So to do that, I got to go to math, scroll down here to pick random. So I can plop that in here for X. And so it's going to pick a random from 1 to 10. Notice he's just bouncing around in the corner there. So that doesn't really do much good. But if I go to scene, remember I can get screen width, and I can put that in. I missed it. There it is. And where the 10 is. And now, remember I only changed my X. Look at it bouncing across the screen at the top. We got some stuff going on here. So we're going to include some other code. All right, let's change the Y. So I'm going to go to math and pick random again. Put that in my Y value there. And now notice that it's getting a little bit because it's going from 0 to 10. But I need to go get screen height for Y and pop that in. A little off my screen there, but hopefully you can see what we got there. So pick random 0 to screen width and pick random 0 to screen height. Now he's bouncing off the screen really fast. So maybe I don't want that. Maybe I want him to go a little slower. So I'm going to put pause in there. Not quite ready for him to move around the screen. I'm going to put pause. And you see now he slows down just by pausing that 100 milliseconds. So but maybe I want him to kind of move at a different rate kind of every time. So I can mess around with using the index variable because remember the variable, and again we can see what's happening with our variable. Take a look and see in our debugging. Pause. So right now it is 4 and then it goes to 5, which then it stops and starts over. So notice my index goes from 0 to 1 eventually. Hopefully there it is. There's 1 and then it goes 2. And so my index is changing. So that's helpful to know. And I could use that in my loop to change kind of the speed of my fish each time it goes. So I'm going to mess around with it a little bit, just try some things out. I'm going to go back to the math. I'm going to pull in just regular old math and pop that in here to my pause. Because how much I pause is how much he moves. As you can see, my pause is now 0 plus 0, which is 0. So if I throw index in there, so pop in index into one of those zeros, he's still moving pretty quickly because the index is only 1, 2, 3, 4. So let's try making our index go to 50. But still, remember that's not very much because we're talking, oh, he slowed way down milliseconds. That's not very much if he's going to 50 milliseconds. So, but it did slow him down quite a bit there. So you can try different things. Maybe we want to do some location. Now, right now, what's it going to be? It's going to be 0 again. So we pop it around pretty quick because 0 times index is going to be 0. For some reason, it doesn't seem to be 0 though, does it? Maybe we just need to restart. All right. So let's see what he does when I have 0 times index. Let's restart and go away from debugging. So he's still moving. So messing around with that index value can really change his speed. So I'm going to put 100 in here, 100 times index. So, and because index is changing, then it's also changing how fast he goes. So if I take a look over here, oh, I think he went off the screen. He shouldn't have gone off the screen. I lost him. Let's restart. All right. 100 times index may not have been a good idea. It may be a little too slow. Let's do 100 divided by the index. Notice that he's popping around pretty good now. Remember that index is changing. And so as the loop continues to get higher, he's going to jump around faster and faster. So you can increase how fast he goes over time by using that index inside the loop. So I want to show that. That may not be something that you've tried before, but you can just play around with your math here and try different values using the index or try different values moving to. But right now I'm just having the fish hop around the screen. Nothing real advanced, but it's kind of cool to try that out and see what the index value does to change the speed. I reset again. I got play. But it should get faster as time goes on. So that's something you can think about as you start thinking about your program that you're going to use for the create task. So hopefully you were able to follow along there. Again, you can try different sprites. You can try different numbers. I was just plugging in numbers and testing stuff out. You can obviously use other sprites things. You can mess with velocity. You can just change one value at a time. There's a lot of other things you can take a look at in there in the sprite section to have your sprite do. All right, we're going to move into a section where I'm going to have you try to do a little project on your own with a loop. When we finish this one, I'll probably step through it with you too. So I'm going to give you a chance to try it on your own, but then I'll come back and show you how to do it and not just put the solution up. I'll go through it with you too. So let's pop back out to the PowerPoint and I will show you or give you some instructions here. And I'll do a timer again like I did last lesson. It's a little trickier here. So I want you to start a new project or just add to what we had right there. I want you to use a for or a while and have your sprite count down from 10 when the program begins. So remember we did a sprite say, or have a sprite have a bubble above it where it says something. We did that before, so find that in the sprite section. And then have it count down from 10. So you'll need a variable, and don't forget to pause, otherwise it'll just show you the last number. To have a sprite say a variable, you'll need a join, and I talked about this earlier, but it's down under the advanced section and then text. And notice there's a join. So, and you will need that, and you see I have it here. And then you can do a join with only one thing, but you can't just type the word number into this section because it'll put quotes around it. Remember, we don't want the word number to show up on the screen. We want the value of our number to show up on the screen. So it will display our countdown. So you'll need this join. So you get a join block and you put it out here, and then click on the minus on it, and it'll make it so you only have one item. And so then you can put a variable value on the screen. So that's a new thing, and that, you may have done that in another programming language, and it wasn't as difficult or as tricky as this. So I just want to make sure you saw how to put a variable on the screen. You do need to use that join with down in the text of MakeCode under advanced. So I'm going to give you 3 minutes to try this on your own, and then I'll come back and walk you through it. So right now I'm going to start the timer. If for some reason it takes you a little longer, you can always pause and then continue on after the 3 minutes. That's the end of the 3 minutes. If you want to pause right now because you're not quite there yet, that's fine. I'm going to go over and walk through the I think you forget a little tip there maybe that you want to do this in the on start, but we'll go take a look at that right now. So let me download the PowerPoint and head back over to MakeCode. So I'm just going to add it to what we did earlier with our fish. So basically I'm just going to add a countdown to the start before he starts moving around the screen. So I'm going to put my code in up here. I'm going to use a while statement. So I'm going to go ahead and go to loops, and I'm going to pull out while, put that into my start. So for a while, and we want to count down. So as I showed earlier, a variable might be a good idea. So if you use a for loop, it kind of has a built-in variable, but I'm going to use a while loop because I feel like I have more control over what I want. So I'm going to make a variable called number, and then I will be able to set my number. So again, I wanted to make a countdown from 10. So then I probably want my number to start at 10, and I'll go ahead and get my sprite to say that. So there's my sprite, and right now it's a while true, so it will be able to it should say it all the time. It's going to say 10. Remember I said if you go and type number in here in this programming environment, there's no way to get rid of those quotes. I tried. It's like, okay, they won't go away. So you have to go down here to advanced, and in the text section you have to pull out a join and pop that in. Now I don't really want to join or connect to strings like they have there with hello world. I just want to be able to put my variable in there. So I just need one bubble to put that in, and I can go to my variable section, pull my number, put it in. So that's what you have to do to get that to show up on the screen. For some reason my autoplay is not working, so I have to go here and play. And right now mine is not seem to be working at all. I'm gonna get rid of this just to make sure that that's not a problem. Looks like I may have to get this started. I'm gonna go back out and come back in because it doesn't seem to be working right now. Get it reset there. So we should see the fish on the screen right now. I'm not sure what's happening, why I can't see my, oh, there's my fish. Okay, so now he's back, and now right now, oh, my while true doesn't seem to want to work. So let's take a look. Seems to be going kind of slow. My fish is disappearing. I'm not really sure why. Okay, let's go ahead and mess around with this while, because the while true is just gonna say the number, but it should still be saying the number. Let's make sure that it's only saying the number for a certain amount of time. Let's go 1 second. And then I need to change my number. Oh, I think maybe we need to put a pause. See if that helps get code to work better over here. Yay, that's what I wanted. I wanted it to say 10. Yay. So right now it says 10. That's all it does. That's not cool. We want to count down. So my while true. So I need to change number. So I'm gonna go to variables and get a change number. I change it by 1, and it's gonna go up. And so right now it's counting up. Oh, look, that kind of worked. But I want to count down. So I'm gonna do -1, and then as it restarts over there, okay, I got 10, 9. Okay, but now remember, my while is a while true. Oh, while true means what's gonna happen? It's just gonna keep counting down. It's gonna keep going negative. So I don't want that. I want it to stop. So I'm gonna put some logic in my while here. So I'm gonna pull in one of these here blocks to comparison. So I wanted to do it while the number. So pull a block out from the variable section while the number is greater than or equal to 0. I'll have it do 0 too. So now it should count down, and it's going on my screen over here. It's count down. Let's see if it stops. Cross fingers. Hopefully that worked, right? And stop. If you didn't do the time here, it would have left the 0 on the screen. So you want to do that. And the pause is obviously very, very important, as I said there earlier. And then our changes the number. And so this is a typical while loop that you might see where you're just using the numbers to count. Again, this could have been done with a for loop as well. The for loop here does not really let you change that 0. So it would have been a little trickier to do the for loop here in MakeCode. So remember that you can always use a while loop and put your condition here. So while the number is greater than or equal to 0, very much like a for loop, you just have to do the stuff outside of the while, and inside change your number. So I'll put my other blocks back in, and I don't know why mine wasn't working very well earlier. I'll throw it in here. So basically it's doing a countdown, and we're going to have that sprite move randomly once the countdown happens. So I'll show you how that kind of worked here, even though I lost that code earlier because I thought it wasn't working. It was causing my program not to work. So there could be times just like that it struggles to work. I did a restart, open the program again. There's lots of options you can use there. Just pulling out the blocks that I did earlier so that we can see if, and sometimes I get my blocks like that mixed up and they pop around. The good news is the block doesn't go away. It just usually gets hidden behind another block. So if you accidentally pop the wrong one in like that, you just do it again, it pops them in. It doesn't lose them, which is really nice. So right now I do need a pause in there, I think, though. Makes a difference. I'm just going to put a pause in. I'm not going to worry about using my index right now. So it should count down to 0. And once we hit 0 here, our fish should move around again and just randomly picking spots around the screen. So 0, oh, he got kind of stuck. Oh, but there he goes. Oh, but he's moving kind of slow right now. Again, my pause is a little long. So maybe we'll pause him less and then he'll move a little faster. But we're going to go through the countdown again. So hopefully you were able to get that up and running. This code was a little trickier, so I went through it. But remember, while loops can be used there. And so I just had it say the number. Got to pull that join, which is down here in the text section. Because remember, if you just had it say number in quotes, it would have put number on the screen. We didn't want that. We wanted the value of number. So you had to use that join for that. Hopefully you were able to do that. If not, pause, go back, check something that I did there. I'm going to go back out to the PowerPoint now and finish up today's lesson. You can join in again. We'll talk about what's coming up next. Again, prior to this, I just did a quick lesson on how to get started in MakeCode. And so hopefully you're able to get started in MakeCode now and use some of the tools that you're going to need for the create task. So before those next lessons, it'll be a few days before they're available. You'll want to try it out, try to think about what you're going to do for your create task and try it out in MakeCode if that's what you're going to use. So today we learned how to use loops in our project. So we used a for loop and a while loop, and this should begin to help you with the create task. So remember the instructions that iteration is one of the items that you should use in your program. Tune in next time, and this is an important lesson to learn about using functions in this environment. So functions are a very important part of the create task. So what we've done so far hasn't quite met the create task requirement yet because we do need to use a function, one of our own functions, and not one of those on events that we've used so far. So keep that in mind. It'll be a few days before the next lessons are posted, but we'll do functions and lists the next time, and hopefully you should be able to then work on your create task again on whichever device it works in. Any browser, you should be able to pull this up and work on it. So hopefully that was helpful today with loops. If you saw there's some issues with it, just refresh, get going, and it should come back up. If you do have any device or internet access issues, or you know someone who does, please contact the College Board to let them know, and they're trying to work on solutions so you can do the submit your create and explore task to the College Board for credit. So visit cb.org/tech. Thanks for watching. I will see you next time when we talk about functions. Hello, welcome to another AP Computer Science Principles lesson today. Today's lesson is again brought to you by me, Mrs. Julie Alano. I teach at Hamilton Southeastern High School in Fishers, Indiana. Computer Science Principles, all kinds of other computer science classes as well. Super excited to move on with MakeCode Arcade today. So can't wait to show you more that you can do with it and to give you some really helpful things for doing your create task. So let's jump right in. So the lesson overview today, we're going to use if or selection statements in this new programming environment that I showed you in the last lesson. So hopefully you covered if or selection statements in your own class before this. They're also called decision statements. And so the learning objective where you find this again is 411. So develop an algorithm for implementation in a program, which is something you have to do for the create task. And so today, before we already talked about sequencing, and so today we'll be covering selection. So my little title here was off there. So yeah, sequencing previously covered and iteration will be covered on the next lesson. But we are on selection today. So selection uses Boolean conditions to determine which of two parts of an algorithm is used. So we're going to be able to have the computer make decisions for us, and that's what we're going to start out with. So again, every algorithm can be done with sequencing, selection, and iteration. So this really hits, and we're going to move on to talk a little bit more about the create right now. This really hits what you can use in the create task. So learning objective 551 says employ appropriate mathematical and logical concepts in programming. So when you do an if statement, you are employing logical concepps. So this really helps you. Here are some of the directions from the create task, which hits what we're talking about today. The program should draw upon mathematical and logical concepts such as the use of numbers. We'll see that a little bit. Variables as well. Mathematical expressions with arithmetic operators, logical and Boolean operators, and expressions. We will cover that today. Decision statements, covering that. Iterations and reflections, those come later. But all kinds of stuff in there that your program should draw upon that we're going to cover today in today's lesson. So, and also from the create task directions, the program must demonstrate use of several effectively integrated mathematical and logical concepts from the language being used, and implementation of algorithms that integrate other algorithms and mathematical and or logical concepts. We're going to build on that, but you will see some of these aspects today in the lesson. But as we go through all these lessons, we'll build on those topics to make sure you have a good foundation in this language of how to make your create task. A little bit more from the create task. You will have to explain how programs implement algorithms. That's part of the create, is that you have to make your program, but you also have to then do your written responses, which part of that is to explain your algorithm. So specifically today, we are going to introduce variables, and so program instructions may involve variables that are initialized and updated, read, and written. So we're going to see variable today, which also helps you to explain how a program implements an algorithm is using that variable. So those are lots of stuff in today's lesson. So I'll try to go slow when I demonstrate, but you can always pause the video and follow along and try this on your own device. So we're going to move into what you need to know. So I've screenshotted some blocks here, and I'll pull them up over in the environment here. But this section, the logic, that's what we're going to take a look at today in the MakeCode environment. And you can see there we have if else. These pluses and minuses are helpful. So if you pull out an if else and then you decide you don't need else, you can just click the minus and bye the else. Comparison, so you can see the shape of these will fit right in there to use in your if statements. And then we have Booleans too. So and, or, and not. Again, this should all look very familiar to you, hopefully, and you should have covered it in your class already this year. So we're just looking at it in the MakeCode environment. Down here, we are going to make a variable today as well. So you see the variable section. There is a block. You click on it, it makes a variable. You can name the variable whatever you want, and then set its initial value. Update them as the code goes on. So we'll take a look at that in today's lesson as well. When you get there, then you also start to involve some math. So notice that we can do all of our regular math operators here. We also have remainder of. You may know that as mod. We have ones that'll find the min and max of some numbers, absolute value, square root. You got other options here, and pick random, always a good one. So remember that these over here wouldn't count as much. The remainder of would, but they wouldn't count as much for a mathematical piece in the create task. So if you're looking to include mathematical concepts, you want to stick to your actual basic math operations over there. Pick random doesn't really. You're just using someone else to find a random number for you. So keep in mind that there's all kinds of math there. Pick random fun, but may not really meet those mathematical requirements, even though it's in the math section on this environment. So we're going to move into some guided practice. So I'm going to do a couple examples for you and show you what's going on here. So I'm going to guide you through a quick project. Actually, I think a couple of them. I'll pause occasionally to make sure you're able to follow along. Feel free to choose different colors, pictures. Don't spend too much time. You can get lost in picking out different pictures, different colors, and all that stuff. Once we complete some code together, I'll give you a chance to code on your own. So we will have a time for you. I'll give you an instruction of something to create, and I'll give you a chance to do it before I show you a solution. So that's the one we're going to do. Oops, I'm going to exit the slideshow, and I'm going to head over to the environment. So if you didn't join us last time, we are in arcade.makecode.com. That's all you got to do is type that into your browser. It should work in pretty much any browser on any device, and then head over there. We're going to use those sections I talked about. So if you haven't seen it yet, there's a logic section. That's where I showed those blocks from, and the math section is here, and the variable section is here. So we're really going to focus in on that section today. So but first we kind of need a sprite or something on our screen to get it started. So let's go up to sprites, and again, that first one is to create a sprite. So as soon as our game starts, we're going to create a sprite. I'm going to continue with my theme of a duck. So I'm going to pick out one of the ducks here and say done. And so once you do that, that, you should see your duck on the screen or whatever you chose as your sprite over on the simulator. We're going to just have the duck ask a question, or your whatever your sprite is, going to ask a question. So I'm going to have that do it when the program starts. So I'm going to go down here to my sprite say. So there is a say feature there. It does allow you to type. We'll talk again later, but you can only type in that block, because as soon as you undo, those quotes go there. And as you should know, anything in quotes is a string. So if you do introduce a variable that you want to display on the screen, you will need to use the text feature. And we'll talk about that again later in this lesson, I think, or the next lesson. But we'll show you how you can put a variable on the screen. It's not quite the same as it may be in another environment. So right now I'm going to type out a question. So we're going to mess with those effects again, like I did in the last lesson. So I'm going to ask, do you want bubbles? And if they want bubbles, I'm going to have them press A, or confetti. So those are two of the effects. So if you so type in my message, and you can see over there on the screen that the message scrolls and it's asking a question. So if you remember last time, we did do effects on our sprite. And so if you scroll down here, right, the first one under effects, these are all the effects you can choose. So you can use whatever you want. You can get a little lost in there, so make sure you just pick one, kind of go with it. So again, I did bubbles or confetti. So remember that we'll use that block again here in a second. I just want to make sure right now you should have a sprite on the screen and it's scrolling a message or a question. So then we are going to use some blocks to, based on that player's decision, we're going to make that effect happen. We're going to use a block from the game section for this one. On game update is pretty helpful and basically updates throughout your program run. So it's almost like a loop. So we'll get to that again in another lesson, but no, it will update positions, velocities, whatever, and especially after a button is clicked. So when one is clicked, it will run the code, this code in the game update. So and it does it every so often too. So it's a really helpful block that you can use in your coding. We're going to jump into the logic then. So to determine which one they pressed, we need an if statement, and I need an else likely. So and then I need a block, and right now we're just checking a button. So we're going to use the controller here. You see this shape is the right shape to go into my true. It's sometimes a little tricky, but you want it to turn yellow, and then it should pop into the slot there where it said true. So right now I have if the A button is pressed, and so up here I said A was bubbles. So I'm going to pull in that one, which again I got from the sprite section. You have to go down to effects. This one right here. I'm going to use another one in a second, so I'm going to pull it out again. And so I said A is bubbles. So I'm going to click my drop down list and select bubbles, which is kind of down towards the bottom. If you don't select a time, then it'll just bubble for forever. So it's a good idea to just have it bubbles or whatever you're doing for just a little bit of time instead of just leaving that to the default, which is cool. So right now I can test my code. It's always a good idea, right? It's part of the iterative development process, which is on the create task. So I'm going to do a little code. Now I'm going to test it out. So I should have, if I click the A button, I get bubbles. Oh, that's so cool. There we are. So A button works. Good stuff. Next up, we'll do our B button. So there's other buttons, and let's test out how the else kind of works here. So if I put this in, and again we had B. Oh, look, right now it's just spraying away. So the else is happening all the time. For my B, I said confetti. So I'm going to go change it to confetti first up. And you see that it immediately runs, and we've got an unlimited amount of confetti happening over and over again. I like to limit the amount of my effects. So I'll change it to a second. But the reason it's continuing to go is because the A button is not being pressed, and so the else is happening all the time. So I will need to click this plus so that I can do it else if, and know, that I only want to do that when the B button is pressed. So I'm going to pull in another button press block, put it here in the else if. Now right now it says if A is pressed, so I'm going to change that to B, and then I have my block for when I press B. So we stopped putting out the confetti, which is good news. And so now it should only do something when I click my button, when I press a button. So if A is pressed, I should get bubbles. Else if B is pressed, then I get confetti. And right now I'm not going to use the else. You could, but I'm just going to go ahead and eliminate the else from the block there by clicking on the mice. So it should update whenever you change your code. And I'm going to head over and click my A button, and I get bubbles for a second, and then hit my B button, and I get some confetti. Notice that it only happened once. Again, by changing these times, it only happens once and just does it for a second. So kind of fun. Just a different option there of A or B. So we worked on a little bit of asking a question and then using the buttons to determine what the user wants to have on their thing. And again, you can obviously modify this to do some other things, but this logic here is really helpful and something that you'll need to use in the actual create task. So it should be a pretty cool way to use an if statement and add some more logic to your program. Now we're going to do another one. So I'm going to lead you through. So hopefully you got that one done. I'm going to give you a second here to make sure that you got your A and B buttons to work. I'm going to do another if statement. This one involves a variable. Like I said, we're going to do a little bit more with that and involve variables which are also needed on the create task. So hopefully everybody got a question up and you did some effects and you're able to program your buttons there to do what you want. So that is the first example of an if. I'm going to do another example before I let you try something on your own. So I am going to just clear out. You can start a new project or clear out too. Sorry, but I'm just going to put all my code in the trash. I'm going to need a sprite, so I'm just going to get rid of that part right now. And I'm going to change my sprite. I decided I don't want to duck anymore. So I'm going to go use, I think I'm going to use this tree down here. So I'm going to change that to my sprite. All right, I got a tree on the screen. Cool stuff. This time I'm going to use a forever loop. So again, it's a loop and it's just another way to kind of get your code to happen, because if you look at the if statements, you notice they have a dip here. So you can't just throw an if out into the blocks. You got to put it in something. So I showed you that you could use the on game update or you can use forever. We'll talk about loops more again in the next lesson. So if you want to know more about how those things kind of work, obviously forever, most of you have seen that before. So we're going to pull out some logic though. I'm going to go ahead and put in if else. Not sure I'm going to use it all. But the goal of this project is I am going to make the tree go back and forth across the screen. So to do that, we did something in the previous lesson where we used moving to the right is positive and moving to the left is negative. There's a lot of things to keep in mind here. So we have to keep the tree on the screen. I want to move it back and forth across the screen. I don't want it to go off the edge on either side. So there's a lot of things to consider about this one. So remember that the left side of the screen is 0 and the right side of the screen here, I can use screen width to determine that, and that block is available. So what I'm going to do is I'm going to pull in some other logic here. I'm going to use a less than here. So notice it starts out if 0 is less than 0. So you just got blocks there that you can pull in. You can use the X coordinate or whatever coordinate of your sprite you would like. So I'm going to pop that into that spot. So you can use X, Y, lots of other options there. So if my sprite is less than 0, well, that would be that's off the screen. So I'm going to change that to greater than 0. So if my sprite is greater than 0, then I want to have it move to the right. If it's over towards the left, I want it to go to the right. So I'm going to go ahead and change my sprite X by 5. So right now it just goes off the screen. Not good. Okay, we're just trying things out here. We obviously have an else. So obviously else, if it goes to the left, I want it to go back. So I probably need another block in here else. And this time I'm going to need some logic again. So I need another greater than, less than, one of those. Pop it in there. I'm going to need my sprite X again. So we'll pull in what's the value of my sprite's X right now. And right now I want to see, is it greater than, remember I said we can pull in the width of our screen. So go to scene to find that screen width. And I can pull that in there. So if the sprite is greater than the screen width, if it's X position, then I would want to change the sprite's X by negative. So it'll go back to the left. I'm going to go -5. So here goes. Still didn't work. I'm going to change this. Get rid of that. And right now it's debugging time. There's an issue, right? There's an issue with our code. So what's happening that it didn't didn't change it by -5. So right now it went off the screen again, and unless I change my code, it won't reset. So if I play it, it goes off the screen. So let's think about what happens with our code here. So if it's greater than 0, well, this is also greater than 0. So that doesn't really do me any good. So I really don't want it to be greater than 0. Let's change this to less than 0. Let's see what happens there. So now my tree's not moving at all because it's in the middle of the screen. Where do you think the tree is right now? This is, somewhere 0, probably around 100, 100. So that's not less than 100, and that's not greater than screen width. So it's not doing anything. So the solution here is that we need a variable. We need a variable. So only when we get to the edges, then we need to switch from positive movement to negative. So I'm going to go to the variable section and make a variable. I'm just going to call it num, and I'm going to set my num to 5 to begin with at the beginning of my program. Now, it hasn't done anything yet because I haven't used my variable. So what I'm going to do is instead of having my changes inside my if, I'm going to pull my change down here, and then I'm going to see, oh, and look at that, he moved to the left and he stopped because then it did this up here. So instead of changing inside my if, I'm going to use my variable. So I'm going to change the sprite by the variable amount. So then right now, I can only go off screen. I know we're still working on it. So in here, instead of using the change, I am going to reset my variable. To go to my variable section, and in here, if the sprite goes negative, less than 0, then I want to make sure that my number is 5. If my sprite goes off the screen like it is right now, then I want to set my number to -5, so it goes back the other direction. And look at that, we're getting it to stop right now. Wow, that was pretty quick. Shows over here on the left. Using that variable helps tremendously. So you can see that my tree is bouncing across the screen now, and all I needed was to set the values in the if and only change by the amount that I'm on. So every time this happens, it says, okay, if it's negative, make sure my number is I'm moving it to positive. Else, if I got more over here, oh, change num back to negative. And so it doesn't change the num every time. If it needs to, it changes. So when it changes it to negative here, it's still negative, negative, negative until the if runs and it's less than 0. Then it changes it back to positive, and it runs across the screen the other way. So pretty helpful. I'm gonna go ahead and do debug mode so you can actually see how those variables are working. And so you see right now that the num is -5 because he was moving to the left. And you can play it again, and when you pause it, you should see you pause it and you can step. It takes a little while. Look at it pause back closer to the edge of the screen here, and you can see that when it switches, so it's running, it switches to 5. So when it gets over there so far, it switches to 5, and then it starts coming back across the screen the other way. So this debug feature, which is also on your phones or tablets, really helpful. You can use it to track variables while your program is running. So the step through, you may have had this in your other programming language, you may not have seen it before, but step lets you go one line by line. You see it highlighting on the right, and then the play just keeps it playing, and you can pause it at any time, or you can restart. So that's pretty cool and pretty helpful if you get stuck, or if you weren't sure. I kind of knew how this program worked and helped you out there a little bit, but if you were trying to do this one on your own, this debug feature would probably be pretty helpful. So that's right there down below the screen, and it was also available on the tablet or phone version. Hopefully you got some sprite bouncing across the screen at this point. We are going to move into having you try some code on your own, so I'm going to give you a little task and have you try it out. So hopefully you've seen this one. Again, you can always pause the video and try it more for yourself if you got stuck somewhere, and then try the other one here in a second. But I am going to go back to my slides and give you a prompt of something that I want you to try on your own. So we're going to leave the tree of bouncing and back into the slides here. So hopefully you're able to go through that and see how selections work, and we did a variable, so lots of cool stuff there in the MakeCode environment. So this time I want you, so you can start a new project and use on start to make a sprite, and then do the following in an on game update, or you could use forever. Either way. So I want you to use the if else statement and the arrow buttons to make your sprite move on the screen. Okay, so remember that you can see we did code we saw with the A or B button was pressed. So remember that those can be changed. And so again, don't forget to put your code in the on game update or forever loop. Put your if in there. Use the arrow buttons to make your sprite move across the screen. For right now, just do left or right or up or down. Remember, left or right would use this, change my sprite X, or you can use change my sprite Y. So there's that suggestion of that block. I'm gonna give you 3 minutes. So I got a little timer here to try this on your own. I will share my code after 3 minutes. So if you're worried or not sure you're gonna finish, you can always pause, and we'll do the 3-minute now. I love music here. That makes it a little Hopefully you were able to, hopefully you were able to do that. We're going to take a look. So if you didn't finish and you want to wait for me to show the the finished version, then go ahead and pause your video. I'm going to leave the slideshow maybe, and then go back out to MakeCode and show you. So there's the tree again. I'm going to go, I have this solution. I'll try to find which project it was that I did this on. I'm going to try this one, I think. So nope, that's the one we just did. So there it is again. We're going to see the tree popping across the screen again. All right, so that was a different one then. Let's try it. There it is. So I use the on game update here. And so right now I'm going to have a strawberry on the screen, and that's it. But here's my code. And so it should, if the right and left buttons are pressed, I can get my strawberry to move. Now right now, I didn't do anything to keep my strawberry on the screen, but I just wanted to get my strawberry to move right and left. So hopefully you were able to do that. So So notice I just did a quick little if else if depending on which button was pressed and changed my X by positive and negative. So that was just a quick little example. Again, obviously a variable is very helpful. You could make the program a little better with that, but I just wanted you to try a little bit of an if else. All right, back to the slides. Again, you can always pause if you want to work on that further. So that is pretty much it for today's lesson. So we're going to move into what you should have gotten out of it. So today we learned how to include an if or selection statement and variables in our project. So this should begin to help you with the create task. So below is a reminder of some of the instructions. The program should draw upon mathematical and logical concepts such as use of numbers, variables, mathematical expressions, logic, and Boolean, and decision. So all those things we hit on today. So that's what you need to start thinking about including in your program for the create task. And tune in next time as we learn about loops. So we did a little bit with loops today as we use the on-game update and the forever, but we'll talk more about those and we'll see for and while loop, which is what you may have seen in another language. And then in the future, there will be lessons that include functions and lists. Functions very, very important as we move into you doing the create task. So we will cover that in a later lesson. Thanks so much for joining me today. Don't forget, if you know someone who has trouble, doesn't have a device or doesn't have internet access, head over to this page on the College Board website, so cb.org, and let them know, and they're going to try to help everybody out so they can be able to do their task and submit to the College Board. Again, thanks for watching. See you next time. Hello, and welcome to another AP Computer Science Principles lesson. I am Mrs. Julie Alano. I teach at Hamilton Southeastern High School in Fishers, Indiana, so just outside of Indianapolis, Indiana. I've been teaching AP Computer Science Principles since it started as an AP course. Love this class, and I'm so excited to talk to you today about a programming option for you to use at home. So let's jump into the lesson overview. As you may know, for the AP exam this year, we are only doing the Explore and the Create. So what I'm here to do today is to help you with programming from home. Is the programming language you learn not supported by the device you have accessed at home? So maybe you only have a phone, maybe you only have a tablet, maybe you're on a Chromebook. Things are different than maybe they were at your school. So today we're going to learn a new programming language that can be used on phones, Chromebooks, or tablets. I tested it out on my phone myself, my iPad. Sorry, I don't have a Chromebook, but I tried everything. I think it's going to work really well. I'm excited to share it with you today. I wasn't aware of it until recently. So it is the Microsoft MakeCode arcade programming environment. There are many different versions of MakeCode, so this is a certain one, and that will be just introducing to today on this lesson. So I will introduce you, show you how it works, how to set up a project on it, how to get started on it, and make a quick little project for today. So based on that, these are the learning objectives and essential knowledge statements that we'll be covering today. So the hope is that you have covered most of the programming topics that you need for the create task. We are going to review those in the lessons that I do today and another day. So in today's lesson, we'll just focus on sequencing, which is just basically that your code happens in the order that it appears. And that is part of the learning objective that is on the create task, and that is to develop an algorithm for implementation in a program. So we know that there's sequencing, selection, and iteration. Today, we're only going to be doing sequencing. Selection and iterations will be covered in later lessons. So know that, yes, you probably do know, I hope, and based on the previous lesson for CSP, that you need to develop an algorithm for implementation in a program, and that's one of the big parts of the create task. So an algorithm can consist of sequencing, selection, and iteration. So that's what we're thinking about today, is just putting some code in, making it run, just really getting used to the environment. We'll cover these other topics in the next lesson. So hopefully you have some knowledge of programming language. That's our goal, is to just show you another way to use your programming knowledge. So that's what we're going to head into today. So what you need to know. Here is the link to get to this programming environment. Again, the programming environment is MakeCode Arcade. So you see the link right here, arcade.makecode.com. Really easy. You should be able to just type it in. It will be added, I think, in the video notes, but you can just type it in. It's real short. If you visit that, you should see a page like you see on my screen at this time. From this page, you'll be able to make a new project. You see I've got one here. And if you want, go ahead. If you want to follow along in this lesson, that'd be great. If you want to go ahead and make a new project and give it a meaningful name. So, but this is what you should see. The good news is your projects will save. So if you make multiple projects, they'll save right down here. You can do a download feature to save them to your device if you're really worried, but we'll talk about that later. I do want to show if you're on a phone or a tablet. So this next screen, so once you make a new project, this is what it will look like on a computer or Chromebook. So you will see that we have different types of things that we can add. Notice that I do have the advanced section expanded. We will use that eventually. You see an emulator over here. So you are going to be emulating a little game on this device. So it will let you press buttons and test it out, and all you need right there. Your code will show up over here on the right. And do notice that you can switch from blocks to JavaScript. So if you're more comfortable with typing code, you can do text or you can do blocks. It's up to you. You can switch between. So if you want to use the blocks to help you know what you're able to do and pull those over, and then switch to text to do some modifications or adjust your code, that's fine as well. So this is just the home screen. And as I said, it does work on a phone really pretty well, or an iPad or any other sort of tablet. And so on your computer, you will see it this way, and it's very easy. You can see what happens over here. You can stop, you can run. You can go full screen with your game if you want, which might be good for when you record for the create task. So you can do that here. There's a save button if you're worried about saving as you go, or if you're worried that your internet may not be real reliable. On a phone or a tablet, here we go. This is what it looks like. So this is a direct screenshot from my phone, which is an Android phone, but I would assume it was similar. It's from within, and I did test it on the iPad as well. So this is from within the browser. So whatever browser you want to use, Chrome, Safari, whatever, this is what it will look like. So you'll have to click on these sections to see the blocks, but then you can pull the blocks out here into the coding environment. Notice I got some helpful stuff here. So this is your game screen. So it's a little smaller there on the phone, but this is where it will show what you're doing as you go. But in order to actually test and run it, you need to click on that. So by clicking on this black little screen right here, which will show what you're making, will bring up the game screen, which is on the right. So then this will be your full phone or tablet, and then you can test what you just coded. To go back to the coding screen, it's this little button right here on the right. So that's the full screen mode. So from full screen back to the coding mode. So this again should look the same if you're on a phone or a tablet. And so it really has worked pretty well to be able to do the coding, especially with just blocks. It may not be quite as fun if you do it with text, but blocks, it seems to be pretty easy to pull the blocks out and edit and modify on a phone or tablet. So hopefully, whatever device you're on, you have set up a new project at this point. So make sure you gave it some sort of name. We're just going to practice right now. So you can just call it practice or sample or whatever you want to call it. And we're going to jump in and take a look at how MakeCode works. So I'm going to guide you through an introductory project. I will pause occasionally to make sure you're able to follow along. I go fast very often, so I'll try to make sure and go slow. Feel free to select different colors or pictures. Just don't spend too much time to practice. You can mess around with this all you want between this video and the next video, and go through and try things out yourself. Unfortunately, what we're making today would not meet the requirements for the create task. This is just to introduce you to this programming environment, to let you see some features and things you can do, and to realize that this is something you could use if what you were using in your classroom is not working well for you. I know there's a ton of programming environments, and what you submit when you submit your create task, it doesn't matter what programming environment you use or what language you're supposed to tell. So this meets that requirement, and so hopefully the concepts you learn in your class you'll be able to apply into this environment if this environment works for you, or maybe you just want to try something new and you decide to do your create task using this programming environment. So I'm going to get out of my PowerPoint here and I'm going to head over to the MakeCode environment. So here is my project that I made earlier. So hopefully you are also on this screen. If you're not, again, just go to arcade.makecode.com and head to that website and then click new project and give your project a name. It should be quick and easy there. So we're going to explore some of the block sections. Again, we're going to do multiple lessons on this. So today we're just getting introduced to it. We're not going to understand all the parts of it today, but we'll take a look at some of them. So this does use sprites, and I will create a sprite in just a second. So this is used to create a sprite. You see there are a lot of this section, the physics section, a lot of things you can do with your sprite about moving them around the screen and changing their X and Y coordinates. Should be similar to any other program you use where 0, 0 is the top left corner of your screen. So your X, Y coordinates can be used to move your sprite. And there are different types of players and sprites. We'll get into that later, but for now, and you can really play with that, but for now we're just going to stick to sprites. You can even do fun little effects. We're going to do that. It seemed to be the first fun thing to do. You can make your sprite say something. We'll get into that too. And there's also projectiles. It's a good thing they're on the screen and not actual projectiles. So we will take a look at how those work a little bit today. And there's a ton more things you can do here. We're not going to get to too many of those today, but know that if you're wanting to try something, just scroll through and try the block out. Never hurts to try. So that's the sprite section, which we'll be using today. We'll also be using the controller section here. As you can see, it allows you to do stuff with the buttons on the screen. There is a multiplayer option. We're not going to get into that. So we'll stick up here to these single player buttons and how those can be used. There's also a game section here. We'll talk about this in a later lesson. A lot of this stuff is really cool, but may not help you with the create task. So we'll talk about, what will need to happen in order for you to meet the requirements of the create. But you can always mess around with this and it's really fun to make a game of your own. You can add sound, again, not required or anything for the create task. The scene is a good one and we're going to work with it. Notice that you can change the background color or make a background image, and the screen width and screen height can come in handy at times. So there's also some screen effects. We're not going to get into the tiles, but know that that's there. Some other things you can use down there, but we're really going to stick to the top section here. That's pretty much it for today of the blocks that we're going to cover. Obviously, you see a lot of other ones here, and as I said, I have the advanced section expanded because we will eventually get into some of these advanced topics too. So keep that in mind that there's more down there in the advanced section as you're working or testing out this new programming environment. The next lesson will involve logic and variables and some maths. We'll get into all those things, which again you should have done before. But for today, we're just going to stick to make a quick little scene here with some objects on it. So let's go ahead and set our background color. So you want to just click on that block. It comes out here like this. You can then drag it into the on start and go ahead and pick a color of your choice. So whatever you want to set that background color to. I like a nice spring color there. So now that you have your background, let's add a sprite. So up to the sprite section, and again pull out the block there. If you click on it, it should just pop over, or you can click and drag whichever way you want to do it, and then put that into the on start. We got a nice gray blank sprite right now, so you want to click here on that gray area. It's a free editor, so you can draw whatever you want if you're really into drawing. But I'm just going to go over to the gallery here and pick out, and I'm just going to use rubber duck. I don't know how many of you have done rubber duck debugging, but rubber duck seems like a fun item to use for my sprite. And so once you do that, you should see on your screen on the left that your background has changed and that your sprite is now on the screen. So hopefully everyone has done that. Picked a color, picked a sprite. There's tons of options in there. You can pick out the sprite of your choice and add that over here. So obviously we can see it immediately updates. It's actually running right now. So you see there's a stop button, so you can stop the simulator. Right now there's not much else we can do because we haven't coded anything else on the buttons. I will go ahead and show the full screen. So if you click here, it takes you to a big full screen gaming device, which you can do. Lots of other options in there too. So if you exit full screen mode, and again, that's the same button that you kind of need to use if you're on a phone or a tablet. So just wanted to show that that's there. So what we're going to do is I'm going to go into the controller section and I'm going to use the on button press event. So notice this event has a lot of options. These drop downs, whenever you see a drop down like this, you want to check that out. So there's all the different buttons that are on the game screen that we can select here to code. And then there's different events we can code too. So you can code the press event, the release event, or the repeat event. So we're going to start with the right button. So when the right button, which is over here. So on right button pressed, and we're going to put some code in here to make our sprite do something. I really liked the effects. So I'm going to go into sprites and scroll down to the start effect. So these are really fun. And so you can pop that in and there's a lot of different effects here you can choose. So I'm going to go with a fountain for mine. And then this is convenient because if you don't change the time, it's just going to fountain for the rest of the time, unless you stop it. But for now, I'm just going to have it fountain for 500 milliseconds, which is a half a second, or you could adjust it to change to those different times there. So I'm going to test my code. Very good to put some code in, make sure it works. So right now, if I go over here, this program is running. And if I click on the right button, my duck has a fountain. So you should see some things coming out of it. Maybe I want it to fountain a little longer. Maybe it'll be more fun that way. Let's see. So let's click the right button. Oh yes, more fountain coming out. Every time I press it, we get more fountain. So that's an effect that you can do on a sprite. Any sprite can add those effects. Now, since it is the right button, I thought maybe we should move our sprite to the right. So I'm going to add another block to that same section. So I'm going to use the change my sprite. So if I just pop this one in right now, change my sprite by 0, change my sprite X. So X, since I am coding my right button, X is going to be this direction. Yep. So I'm going to, but changing it by 0 does nothing, I think. So if I click right now, I still get my fountain, but the X is not changing. So I'm going to go ahead and go with 5 and see what we get there. So the program should have reset. Once you did something in your code, all I got to do is go here, click right. Oh, and he's now moving to the right. Unfortunately, he's going to go off the screen, and right now I can't bring him back. We'll have to fix that, huh? So something to think about as you're coding is, yes, they can go off the screen. So he's now fountaining off the screen to the right. So with that, I'd say we code the left button press now. So let's go back to controller, pull out an on button press block. I'm going to move this one out of the way and pull up this one up here. So as I said, I think I want to do the left right now. So drop down on left button press, and I'm going to have the sprite do another effect. It'll be fun. We'll go left, we'll do one effect, go right, we'll do another effect. So for this one, I will have, let's see, I think I like the smiles. I'm going to have smiles effect, and again, I'm going to do it for a sec. Okay, so let's test. So I'm going to go left button, and so I got some smiles coming out of my duck. They go down, pretty cool. And he's not moving because I haven't done any code to move my duck yet. So this way he moves, and then if I go left, he's not moving, but I get smiles. So I want to add that change my sprite. There it is, and pop that in. So in order to go left, remember that the top left corner of this is 0, 0. So to go back that direction to the left, I need to use a negative number. So I'm going to put -5 in for that one. Still changing X because I'm just going left to right. And so I'm going to pop over here and should be all set. You don't have to wait for anything. So I'm going to go right and left. So duck's moving, I get smiles, I get a fountain. I can move him across the screen as much as I want. So hopefully you got your sprite to move with buttons, and it has some effects that you liked or picked out that was fun for you. So pretty cool stuff, right? So I'm going to do one more thing here, and then you can test out some stuff on your own. But I wanted to show another one. So kind of a cool one to do the projectile. So let's go with another controller. So this time I want to use the down button because usually when you hit down, something will come out. So I'm going to change this to down. And then if I go to sprites and I scroll down to the projectile section, you can set a projectile with a velocity. Just going to use the default velocity here, and you can do it input to projectile from your sprite. So I'm gonna go ahead and do that one just to make sure it comes from where I want. It's a big block, so I'm gonna pull it over here to make sure you can see everything and maybe move my left and right buttons down out of the way. So a big block there, and right now it's not doing anything because I haven't selected a picture for my projectile. So click on the gray, and again, it brings you up with an editor. If you want to create your own item, you can. I'm gonna head over to the gallery, and I think I'm gonna use strawberries as my projectile. You can choose whatever you want. I'm gonna go ahead and select done, and you should see over here, if I go to the screen and I hit the down button, I get strawberries coming out of my. Pretty exciting, right? So we can move and then have strawberries, move and have strawberries. So pretty cool stuff. It's pretty easy to add effects and get items added here. Once again, I want to remind you though that while this has a little bit of sequencing in it, this doesn't really meet the requirement for the create task. The next few lessons are going to get you those building blocks that you really need. These on events are kind of tricky when we'll get to later how you can use them to also add in your own abstraction or function, which we will talk about as you can see here. That'll be very important as you plan your create task. So know that it's fun and really cool stuff in here, but that you will need to add some more items and make sure that you still meet the requirements of the create task and not just make a fun little game. And remember, looks aren't that important either. So while we had some fun with the fountain and the smiles, they aren't really going to make much difference when you do your create. So we'll want to stick to things where we are changing our x and y values, and we'll introduce variables and loops and ifs, and so that will help you meet those requirements for the create task. So hopefully you were able to make your own quick little introduction to your first project on MakeCode and picked out something you want there. You probably have tried multiple things now while I'm talking even. So if you haven't done so already, try something on your own. Pick out another block that I didn't look at, or do maybe a button, do something. But go ahead and try something on your own. I'm going to give you a couple minutes here, and then we are going to wrap up this lesson. Again, it was a quick introduction to the programming environment. So hopefully you have a chance to try this out on your own device during this video. I do want to point out the download button. So again, this would allow you to download the file to your device, which will save it more if you want. So if you're worried about your internet connection or it not saving in the MakeCode environment, you could download it, which then it can be imported back into the MakeCode environment. So know that that's what that button's for, but really right here is your save button. So if you're worried or want to make sure that you save, which actually does it, it saves a picture, and you can download it and to reload it that way too. So, but it saves automatically. So if I go back out to home right now, you can see this is my first project right here, and it just says I started it 3 minutes ago, reloads, all set, ready to go again. So it takes a second here to load the screen, but there's my duck again, and everything should work just fine. So you can go back in and out, you can download, you can save it otherwise, so that you make sure you have it when it's time to use it. So if you're just practicing right now, no worries. And you do have some undo buttons down here. And again, let's go ahead and take a look at switch to JavaScript. So at any time you can pull that up and you can see the actual JavaScript code. If you prefer coding in JavaScript, you can do that. And you can see that there's some, it's all kinds of built-in code here. You see it's even got the actual code for your image. So that we made up my duck there. So how it's coded in color. So that's pretty cool. So if you want to switch to JavaScript anytime, that's nice. But you can also just stick with blocks. So as I talk through that, hopefully you tried some other things out yourself or took a look at those things with me. So hopefully this environment is good for you and you'll be able to use this, or maybe it's just something new you want to try right now because there's plenty of time to try things. So I'm going to pop back over to the PowerPoint here and we're going to talk about what was covered today. So short lesson, but it's just an introduction to MakeCode. So hopefully you were able to open up the MakeCode programming environment and make your own first project and see how it goes. And you should be able to continue exploring it on your own, just like I did. Just pull out blocks, try them out, test out numbers, test out values, see how it all works, see if it's something you want to use and it works for you as you're planning your creative task. As I said earlier, tune in next time. We're going to learn about using if and selection statements as well as variables in the math. So a lot more things that help to meet those requirements on the create task in this programming environment. We will also get to loops and functions and lists. So some of that may get a little further on where you may not have covered it. So we'll slow down on those lessons. Those lessons will be a little longer where we'll definitely dive into those topics a little further in case you didn't have a chance to cover those in your class course. We'll let out. So hopefully you got your first project up and running and you had some fun with your sprites and your projectiles and some of the effects we did there. Again, tune in for the next lessons with a few more details about what you're going to need to do that create task. We'll finish up with a couple slides here to close out if you need assistance. So if you are watching this video as a teacher and you know your student may need assistance or you know someone who does, please have them get in touch with the College Board at that address there, cd.org/tech, and they're working on solutions to get devices or connectivity so you can complete the tasks to submit and get an AP score. So reach out, or if you know someone else who needs that assistance, please reach out and help them out. That is it for today's lesson over MakeCode environment, and I will see you on the next one when we tackle if statements.
Hello, and welcome to AP Computer Science Principles video for the Create Performance Task Directions and Scoring rubric. My name is Daniel Bonrigo, and I teach at Riverside Brookfield High School in Riverside, Illinois. I have been teaching AP Computer Science Principles from the beginning. Actually, I was one of the pilot teachers who taught it the year before it was an actual AP course, and then I've been teaching it ever since. Also, I've been part of the AP reading team that goes and scores all of the AP performance tasks submitted by students. And so I'm excited to be here today to share with you the performance task directions for the Create Performance Task and the scoring guidelines. All right, so the overview of what we're going to cover today. First of all, I'm going to take you to the College Board website that shows a lot of just general information about the performance tasks. Then we're going to go through the Create Performance Task directions, and then we're going to go through the Create Performance Task scoring guidelines. Now, I have these links listed here, and these links are going to be available in the description of this video on YouTube, but you can always take a screenshot or a picture or whatever and go ahead and type these in. But these second and third links are available on the webpage of this course. So let's start off and let's go to this webpage. This is a College Board webpage that talks about the Computer Science Principles assessment. So I just want to show you a little bit of what's here. Obviously, you should go here at some point to peruse this. All right, so the first thing that I want to point to your attention, the performance tasks are going to be due at the absolute latest by Tuesday, May 26th at 11:59 p.m. All right, so now remember, the performance tasks this year are going to be the only things that are going to make up your AP score. So it's very important that you have the performance tasks submitted on time according to this date. All right, now if we scroll down a little bit more, all right, you can see the assessment components. Obviously, there was going to be the end of course exam. That is not going to be the case this year. We only have the performance task create and the explore performance task. The information about the explore performance task is covered in a separate video. So in this video, we're focusing on the create performance task. All right, so now scrolling down, there's some other links. Here is a link to submit your work, how to submit your work, exam accommodations, exam day policy, exam tips. A lot of those might refer more to if there was a multiple choice exam. All right, but going down further, all right, is some very important links. Okay, this one, the assessment overview and performance task directions. That is the next document that we're going to be going through, which is available on this website. All right, then there's a template for your written responses for create and for explore. And then if you go down a little bit further, here is the scoring guidelines. So we're going to be going through this towards the end of today's video. All right, and then down here, there's some more important links, some some student samples, which can help you to understand some of what other students have done and how those ones were scored using the scoring guidelines that we're going to be discussing. All right. And then down here, user guide to the digital portfolio, which is how you're going to submit this information, and that is covered in a separate video as well. All right. So let's go back here. All right. So that is what we're going to be covering today. All right. So now, what you need to know. All right. So this is where we're going to spend the majority of our time. All right. So first of all, the create performance task directions. All right. So this is very important that before you set out to start the create performance task, that you understand the directions, what you actually have to do. All right. So I'm going to give you a little bit of general information about the performance tasks. That's both explore and create, but we'll focus on create in this video. Explore information is in another video. All right. So once you understand these directions, you are going to complete the following. You're going to brainstorm ideas for a program that you would like to create. Now, remember, it doesn't have to be some life-changing program or something that you're going to put on the App Store and then you're going to make all this money and you're going to become a billionaire. Right? This is not the idea. You are trying to come up with a program that you can write that is feasible for you to write in about 12 hours of class time or less, preferably less, because you have to work on the written responses and recording a video of your program as well. So I would shoot for a program that you can write in maybe 6-7 hours, something like that. All right. Now, once you come up with an idea, okay, then you need to iteratively design, implement, and test your program and document your progress at each step of program development. All right. So let's talk about this. Iteratively design, implement, and test your program. All right. So iteratively design. So that means you come up with this idea and then you start working on something and then you're like, oh wait a minute, this is way too much. I have to go back and I have to change this. And then I keep working on it and then I get to a certain point and then I test my program and something doesn't work. And so then I go back and I change it again and then I fix something and I go back here and then I test my program and this thing works, right? But then I realize like, oh man, it would be so much better or more simple, easier to use if I change this and then I go back and then I change it again. Right? That is the iterative design and implementation of your program right now. And document your progress, right? So you want to make sure that you write down, okay, this was my initial idea. Then I did this, then I did this, then I did this, then I did this. Oh wait, then I had to go back and fix this because this thing didn't work, right? You want to make sure that you are keeping track of that because that is something that you're going to have to write out. All right. Now, once you have created your program, you've tested your program, and you're satisfied with what it does, then you're going to get ready to do the next few parts, which are what is going to be great. Right? You're going to record a video of your program running. Right? Now, the video must show your program run and be less than 1 minute. Now, remember, it must show the program running. It doesn't have to show the whole thing finishing, doing everything that you programmed into it, doing every different iteration of what is possible for it to happen. All it has to do is show a significant feature of your program running. Okay, remember, it must be less than 1 minute. Now, it may include audio narration, okay? And so it doesn't have to include audio narration. It could just be dead silence of your program running, all right? But it may include audio narration. Now, it has to be a video. Okay? It can't be like a picture of your program. It has to be a video of your program running. A separate video will discuss how you might create the video and some of the challenges with doing that. All right, then you're going to provide written responses to prompts 2A through 2D, right? And so I'm going to cover the prompts in more detail in a few minutes, all right? Then you have to do one more thing. You have to provide the entire program code. So you have to take wherever you program it, you have to give and submit the entire program code, right? So if it's a text-based language, you can just copy and paste and do all of that. If it's a block-based language like Scratch or Snap or App Inventor or whatever, right? Then you might have to do a bunch of screenshots. You might have to take a screenshot of one part and then move it over and then take a screenshot of another part, move it over, whatever. Okay, but you have to provide the entire program. All right, so let's go to this performance task directions and talk specifically about the directions. All right, and so here are the performance task directions. Now this includes both explore and create. All right, but we're focusing on create in this particular video. Explore is explained in a separate video. All right, so now it's important that you understand a number of items here. Okay, number one, all right, you need to be able to create this. All right, you need to be able to create a video and respond to the prompts. All right, so if we go down, okay, one very important thing, okay, computer science principles policy on plagiarism. All right, so a student who fails to acknowledge through citation, attribution, by reference, or through acknowledgement in a bibliographic entry, right, the source of or author of any and all information or evidence taken from the work of someone else will receive a 0 on that performance test. Right, so very important that you understand if you have gotten information from somewhere, like let's say that you couldn't get a particular thing and you had to look it up or whatever, then you should cite that. You should say I got this information from such and such. Okay? All right, now programming requirements. There is not a specific language that is required. All right, it is language agnostic. That means there is no specific language required. All right, so you're allowed to select a language that you feel is appropriate and will meet the requirements of the task. All right, so when selecting a language, you should review the requirements section of the performance task to ensure that your program will be sophisticated enough to implement mathematical and logical concepts, to create abstractions and implement algorithms. So it's important when we go through and we talk about the particular pieces that you need to respond to, that you make sure the program that you create will actually hit those pieces. All right, now peer-to-peer collaboration. Okay? It's important that you understand collaboration is only allowed on a certain component of the create performance task. Okay, for the explore, it's not allowed at all. Right, but obviously that is discussed in a separate video. For create, okay, you are encouraged to collaborate on the development of your program with another student in your class. Now I know if you're working from home, that might be a little bit more challenging, but you still can solicit some collaboration with someone from your class. All right, collaboration is not allowed during the creation of your video or when answering the written responses. Okay, so make sure that you understand. Okay, you are allowed to collaborate on the writing of your program. All right, if you need help debugging, you can do that with another student in your class. All right, you cannot, however, ask your teacher for help when you are creating the program or debugging or testing or anything like that. All right, so now let's continue. All right, when you're preparing for this, okay, you need to make sure that you understand how the programming language works, how you can use abstractions and functions, methods, or whatever programming language you're using in order to make it sophisticated enough. All right, you need to pay attention to the instructions. All right, making sure you understand that your video cannot exceed 30 megabytes or 1 minute. You need to make sure that you know the proper way to evaluate and appropriately cite a source of program code. All right, you need to give credit to the author. Understand the level of detail that's expected in writing your responses by examining the scoring guidelines, which we're going to do in a few minutes, and looking at high-level samples. And so remember, I showed you some samples on that website that you can access, and that will also be covered in a later video. All right, and then understand that once you submit your work to the digital portfolio, that is it. It's out of your hands and you cannot revise it. All right. All right. So let's keep going down. All right. So now this is the explore performance task. So we got to keep going down to page 11 of this document in order to get to the create performance task. All right. All right. So the create performance task. All right. So we want to remember that programming is a collaborative and creative process. So we want to make sure you understand you should be collaborating with a classmate or something on your program, right? Because that is how programming is done in the real world. All right. Nobody is sitting kind of in a little box and programming by themselves. Okay. Your development process should include iteratively designing, implementing, and testing your program. We already talked about this. You should be having an idea, working on it, and then you go back and you fix something, change something, add to it, and then you keep working, and then you test it, and it doesn't work, and then you go back. Right. That's that iterative process. All right. All right. So now let's keep going down here. All right. You should use 12 hours of class time. Now remember, class time, if you're working at home over the next few months, who knows what class time means, I guess, but 12 hours is a realistic time frame. Now remember, that is meaning for the actual creation of the program, testing, all of that, and the creation of your video and the written responses and all that stuff. Okay, so make sure that you keep that in mind. All right, so now what do you have to actually submit? You have to submit a video of your program. We're going to talk about that already. You have to submit individual written responses, which we're going to go through in more detail, and then the entire program code. All right, so general requirements. All right, so let's go down here. All right, remember, you are creating a program of something that is of interest to you. Like I said before, it doesn't have to be some like world, it doesn't have to solve world hunger or, it doesn't have to solve the, coronavirus, pandemic. It has to be something that is of interest to you. Okay, now you have to design, implement, test your program. All right, and then you have to create your video video and your written responses. All right, so you are required to independently develop an algorithm that integrates 2 or more algorithms, and that is fundamental for your program to achieve its intended purpose. So you got to make sure that the program that you design is sophisticated enough where you have an algorithm and that there are sub-algorithms within it. Okay, we'll talk about that in a little bit more detail in the scoring guidelines. Right, you have to develop an abstraction that manages the complexity of your program. So remember, abstraction is something that you can use to hide certain details, right? And then how does it manage complexity? Well, if you hide these details and you use this abstraction over and over and over and over again, then you've managed the complexity by not having to write all of those details out in your program every time you use it. Right? You are required to create a video that shows the running of your program and demonstrates its functionality. But remember, not all of the program's functionality may be shown. Right? That doesn't necessarily have to happen. Then you're going to write responses to all the prompts and submit your entire program code. All right. So program requirements. All right. So you need to use several effectively integrated mathematical and logical concepts. You need to implement an algorithm that integrates 2 or more algorithms and integrates mathematical and or logical concepts. And you need the development and use of abstractions to manage the complexity of your program. All right. So what are you actually submitting? A video. Okay. It needs to be in MP4, WMV, AVI, or MOV format. All right. So remember, if you record a video and it's not one of those formats, you're going to have to go ahead and change the file type by converting it. That will be covered in a separate video. All right. Your video must not exceed 1 minute and 30 megabytes in size. All right. Then you are submitting a PDF of your written responses. So we are going to talk about what those responses are going to entail. All right. And then you are providing your entire program code, like I said. All right. So what are you actually responding to? All right. So 2A. All right. We are responding to the following. You're going to provide a written response or audio narration in your video. So remember, written response or audio narration. So if you narrate in your video, you could potentially lead to a blank. I personally would recommend that you do both. That you do an audio narration when you're creating your video, and then you write a written response. All right. So what do you have to do in that written response? Identify the programming language. I wrote this program in Java. I wrote this program in Python. I wrote this program in Scratch, or whatever you use. Make sure you identify the program. Identify the purpose of your program. This program exists for this reason. Why did I create this program? Okay? And explain what the video illustrates. So you're simply saying like, hey, the video shows my program doing this, and this, and this is why I created the program. All right. So that was not exceed 150 words. Remember, we're trying to be specific but also concise. All right. Describe the incremental and iterative development process of your program. So here's a real important thing. Incremental. What does that mean? Step by step. What did I do? I did this, then I did this, then I did this, then I did this. Okay. Iterative development process. Remember, that means I did all this stuff, and then I realized that something wasn't working, so I had to go back here and I had to change this. I had to fix this. Then I got here and I tested my program, and I realized that it would have been better had I had this as a part of it. So I went back and I changed. Okay. So that's the incremental and iterative development process. But then you also need to focus on 2 distinct points in that process. You need to describe the difficulties and or opportunities you'd encountered and how they were resolved or incorporated. So you might say like, hey, I tested my program and the scoring feature wasn't working, and so then I went back and I realized that I had to add 1 here within this loop, and so that's how it resolved. Or sometimes it might be like I was having difficulty with this particular thing and it wasn't working, and so then I just got rid of it. I just scrapped it because I couldn't get it to work. Right? That is sometimes how you resolve a problem. All right. In your description, clearly indicate whether the development described was collaborative or independent, and at least one of these points must refer to independent program development. Must not exceed 200 words. All right. 2C, capture and paste program code segments that implements an algorithm. So remember, you are doing a screenshot or using snipping tool or just copy paste or whatever part of your program code that implements an algorithm, okay? And that is fundamental for your program to achieve its intended purpose. So you want to take a significant algorithm from your thing. Now, what is an algorithm? Well, an algorithm is basically more than 1 line of code and less than the whole program. You don't want to give the whole program. And I'll talk about more of that in the scoring guidelines. This code segment must be an algorithm that you developed individually on your own, must include 2 or more algorithms, and must integrate mathematical and or logical concepts. Describe how each algorithm within your selected algorithm functions independently. So you're going to say like, oh, this sub-algorithm does this on its own, right? This sub-algorithm does this on its own, but together, right, this is what it accomplishes, and this is integral for my program to accomplish its intended purpose, okay? All right, so that's 2C, all right? Then 2D, capture and paste a program code segment that contains an abstraction you developed individually on your own, right? This abstraction must integrate mathematical logical concepts. Explain how your abstraction manages the complexity of your program. So remember, okay, you're taking this piece of code that you can use to hide the details, and you can use that abstraction in other areas of the program that will manage the complexity. So a really easy way to do this is with a function or a method or a procedure or something like that, where you define this procedure, and then when you call the procedure in other areas of the program, you don't have to worry about the details that are in that, okay? So that is 2D, must not exceed 200 words. All right, then lastly, program code. Capture and paste your entire program code. We talked about that. All right, now, in this part, you're actually going to mark an oval around the segment, the program code segment that you used in 2C, and then you're going to mark with a rectangle the program code segment that you marked in 2D, right? And include comments or acknowledgments for program code that was written by someone else. All right, so that is the directions. That is what you're actually doing. Now, in order to prep for the performance task, obviously, you need to do a number of things. You need to have a lot of practice programs that you can read through the rest of this document in more detail on your own. All right, but now let's go back here. All right, so we've done all of this stuff. We responded to the prompts. All right, now let's make sure we understand what the scoring guidelines are. All right, so scoring guidelines. Okay, I'm going to show you the scoring guidelines because I want to make sure that you understand exactly what the readers are going to use to score your response. All right, then you should use these scoring guidelines to score sample responses to develop a better understanding of performance tests. So I showed you that link at the beginning of this video. That is a place where sample responses are available, and there will be a later video that actually goes through and scores some sample responses to help you understand the performance test even better. All right, so let's flip over to the scoring guidelines. All right, so scoring guidelines. Okay, we are on page 2 of this document. All right, and page 2, 3, and 4 show the scoring guidelines. All right, so there are 8 rows of scoring for the create performance task. All right, they are scored on a binary system, so that means you either get the point for the particular row or you do not get either 1 or 0, no half points or anything like that. All right, so row 1. Okay, what am I looking at? Well, I'm looking at the video and potentially response to A. All right, so scoring criteria for row 1. The video demonstrates the running of at least one feature of the program submitted, and the response, which could be the audio narration or the written response, identifies the purpose of the program, what the program is attempting to do. So remember, purpose means why does this program exist, right? So when you say like I created this program to do this, right? There you go, you stated the purpose. So remember, you got to have the video show one part running and identify the purpose of the program. All right, so now decision rules. This is very important to read through here. I'm not going to go through these in great detail, but you do want to make sure that you go through those. All right, 2B, response 2B. This is from row 2. So now, okay, in response 2B, you describe or outline steps used in the incremental and iterative development process to create the entire program. So remember, this is where I said that documenting your progress is very important, right? So you want to make sure that you're describing what you did. So incremental, remember, means step by step by step, and iterative means when I got to here, I had to go back and I had to fix something, right? Or I got to here and I tested it and I realized that it would be really cool if it did this, and so then I went back here and then I changed it and then I did it again, right? And so once again, you do want to make sure that you understand these decision rules, right? But very important that you remember this process that we're describing is the actual programming process, not the idea process. You don't say like, oh, I want to make this game that does this, and then I realized it would be too hard, and so then I changed and I made a game that did this. You actually want to say like, I wrote this part of the program, then I wrote this part of the program, then I wrote this part of the program, and then I did this, and then I had to go back and fix it when I tested the program. It's about the programming process, not the idea for the program, not the brainstorming. Okay. All right. Now going on. Okay. Row 3. We're still talking about response to B. Right. So now specifically identifies at least 2 program development difficulties or opportunities, and describes how the 2 identified difficulties or opportunities are resolved or incorporated. All right. So remember, you say like, oh, I tested the program and I had this problem, right? And so I had to go back and fix it. This is how I fixed it. Right there, you're talking about a specific instance where you had a difficulty and how it was resolved. So now you have to do 2 of those. All right. That's response to B. Row 3. All right. Going down. Row 4. Now we're talking about the code segment in response to C. All right. So row 4 is a pretty easy row to get. It says the selected code segment implements an algorithm. So you have to select a piece of code. If you don't select a piece of code, you're not going to get row 4. before, right? It's pretty simple. Now, do not aware of functionality following is true. The algorithm consists of a single instruction. So like I said earlier, what is an algorithm? Well, the way that we're looking at it here is an algorithm is more than one line of code, more than one line of code. Now, the next part says it's not included in the response. So basically, you have to make sure that you actually identify this algorithm, right? And then you want to make sure that if you keep going down, all right, the algorithm is not explicitly identified, or the entire program is selected. So remember, what did I say about an algorithm? It must be more than one line of code and less than the whole program, right? So pretty simple. Row 4, I think, is a really easy row to get. All right, moving on, row 5. Okay, now this is a much more difficult row to get, which is also looking at response to C. All right, so the selected code segment implements an algorithm that uses mathematical or logical concepts and explains how the selected algorithm functions and describes what the selected algorithm does in relation to the overall purpose of the program. So once again, remember, you've gotten row 4 because you selected an algorithm more than one line of code, less than the whole program. Right now, you've explained, okay, this is what this algorithm does, right? This is an integral part of my program, right? So that is the criteria for row 5. Okay, so remember, you got to make sure it uses math or logic, right? And it implements an algorithm and explains how it functions and what it does to the overall program, right? So like I said before, there will be some example videos of scoring some samples, and then you'll get to see how some students did or did not get these points for their responses in previous years. All right, row 6, all right, response to C. All right, so now this is also response to C, but it says the selected code segment implements an algorithm now that includes at least 2 or more algorithms. So now remember, you have to have a significant piece of code as your initial algorithm, because within it have to be 2 sub-algorithms. So now what does that mean? So now you're identifying lines of code within the overall algorithm that on their own would do something for the program. So for instance, okay, it says selected code segment implements an algorithm that includes at least 2 or more algorithms, and then at least one of the included algorithms uses math or logic and explains how one of the included algorithms functions independently. All right, so let's say you have this chunk of code and you say, okay, here's this chunk of code and it does this all together. And then you say, here's this smaller piece of code within there and it does this on its own and it uses math and logic. And then here's this other section of code within this and it does this on its own and it uses math and logic. Okay, that's what you have to do to get rows 4, 5, and 6. All right, and then obviously make sure you pay attention to the decision rules here. All right, let's keep moving on to row 7. All right, now row 7, I am looking at response to D. All right, so row 7, the selected code segment is a student-developed abstraction. All right, so remember, okay, it needs to be something that you wrote. All right, so if we go over here, okay, it's important to remember, okay, you're not going to get this point if the response is an existing abstraction, such as variables, existing control structures, event handlers, APIs, whatever. So remember, if you're using a language and there are existing functions that you have access to, those are not student-developed, so that does not count as an abstraction. So I recommend that you write yourself a function or method or a procedure or whatever the particular language that you're using uses, and then call that at various other points within your program. All right, and then row 8, okay, once again, we're also looking at response to D, explains how the selected abstraction manages the complexity of the program. So manage complexity, what does that mean? Well, basically, your program has a lot fewer lines of code because I can use this abstraction over and over and over in my program, and I don't have to write out all of those instructions each time. Right? So make sure that you understand that. Like I said, you can use these scoring guidelines to score some sample student responses, and there will be a later video that also discusses scoring of sample student responses. All right, and so let's go back to our presentation. So now, what have we done? All right, so debrief and summary. All right, you should understand the general requirements of the performance tasks, the specific requirements of the create performance task. You should understand what you need to do to prepare for the performance task. You should understand what you need to do for completion of the performance task, what you need to submit, and then how the performance task will ultimately be scored. All right, so these are the things that you should understand. Make sure you access those links. The links are going to be available in the description of this video. And I wanted to leave you with a song that a friend of mine created for the create performance task.
Write a line of code, make an algorithm ready to explode. Math and logic are essential, sharing pointers, pairing while you're daring, build the app with better abstraction. Hide the details and your users will have fun. Knowing nothing of the code that's hiding, so providing when the game is simple to them. C stands for computer, S stands for science, principles.
All right, and to finish off, we want to make sure that you're aware that we know that not all students have access to the internet or a device. We're working on solutions to help students get what they need to show their best work. If you need mobile tools or connectivity or know someone who does, you can reach us directly to let us know at cb.org/tech. Thank you for watching, and I hope that this lesson was informative. Hello, welcome to AP Computer Science Principles, Explore Performance Task, Directions, and Scoring Guidelines video. My name is Daniel Bonrigo, and I teach at Riverside Brookfield High School in Riverside, Illinois. I've been teaching AP Computer Science Principles for a number of years since the beginning. I was one of the pilot teachers, and I've been a reader for the AP Computer Science Principles reading every year that's been an AP subject, and I'm super excited to be sharing with you guys today the Explore Performance Task, Directions, and Scoring Guidelines. So let's get right into the lesson overview. So today we'll be discussing a few very important items that you need to know in order to complete the Explore Performance Task this year. First of all, we'll be talking about general performance task information, and so this is going to be available at this particular link, but no need to write it down. You can screenshot it or take a picture of it if you'd like, but the link should be available in the description of this video on YouTube. And then we'll be talking about the specific Explore Performance Task directions that are available at this link, pages 6 through 10 of that particular PDF. And then we'll be talking about the Explore Performance Task Scoring Guidelines, which are available at this link, and those will be on pages 5 through 7 of that particular PDF. All right, so first of all, let's go and discuss some general performance task information. So this is a very important link that you will want to access at some point. So you'll notice this is the AP Computer Science Principles. It's available on the AP Students webpage. All right, so this talks about the assessment. All right, and so one very important thing that you really want to make sure that you are aware of. So this year, the performance tasks are due to be uploaded by Tuesday, May 26, 2020 at 11:59 p.m. Eastern Time. Right, and so this is where you must submit your performance tasks into the AP Digital Portfolio. All right, so a later video will discuss accessing the digital portfolio and how to upload and what you need to do to upload those things. All right, but that link is available here as well. All right, so if we scroll down a little bit more, okay, the assessment components. Okay, obviously there are the 2 performance tasks, and then there would have been an end of course exam, but that has been canceled this year. So the only 2 things that you need to focus on this year are the Explore Performance Task and the Create Performance Task. So in this video, we're discussing Explore, and then in another video, we will be discussing the Create Performance Task. All right, so now if we roll down here, all right, there are some other very important links that you want to make sure that you understand. Okay, this is a link to where you're going to be able to submit work, how to submit your work. All right, exam tips, assessment timeline. Some of that is more related to had there been a multiple choice exam. But if we go down here, all right, some very important things. The first one, assessment overview and performance task directions. All right, that is going to be one of the documents that we're going to be going through today, talking about the Explore Performance Task. Down here, there are 2 different templates: the written response template for Create and the written response template for Explore. All right, and then the scoring guidelines. This is going to be the other document that we are going to be going through in a little bit during this presentation. Okay, now also there are some sample tasks that are available for you to view and to practice. So that would be something that that would be good to do. Those will also be addressed in a later video. All right, so back to our presentation here. All right, so you need to go through that website to access the general performance task information, and that relates both to create and explore. All right, but today we are specifically talking about the explore performance task directions. All right, so what you need to know. All right, so this is where we're going to spend the bulk of our time. What do you really need to understand about the explore performance task? All right, so the explore performance task directions are available here. This is the same link that I mentioned earlier, and that specifically is on pages 6 through 10 of that. All right, now there is some general information about performance tasks available on pages 3 through 5, and that addresses both the create and explore performance tasks. We'll be going through that information in a little bit in more detail. Now, when you are getting ready to complete the explore performance task, the first thing you really need to work on is selecting a computing innovation. So the first thing, actually, before you even select, is you need to understand what a computing innovation is. So it's very important that you understand a computing innovation is an innovation that includes a computer or program code as an integral part of its functionality. All right, so you got to remember that an innovation could be anything that is new, that a company's working on, some product, whatever, but it doesn't necessarily have to be a computing innovation. You want to make sure that you don't confuse like a technological or some sort of other type of innovation. So you could have, like, if we talk about like a new car, right? That doesn't necessarily have to mean it's a computing innovation if we're not talking about the computer or the code that is associated with that particular device, right? So a computing innovation is an innovation that includes a computer or program code as an integral part of its functionality. So remember, it could be physical, right? Like a phone or some sort of a smart device, but it doesn't necessarily have to be physical. It could be an application, right? So you talk about all these apps that are on your phone or on your computer or whatever, right? Those things would be considered computing innovation because those have program code as an integral part of its functionality. It could also be something that is more like theoretical, something that is like a system of how people are going to communicate or how people are going to solve some sort of a problem within society. So it's important to remember that could be a physical device, it could be a computer program, or it could be bigger than that and talking about something like e-commerce, something that is a way for people to conduct business or communicate or something like that. So I like to say you want to select an innovation based upon prompts 2C and 2D. And so we'll talk about those in a little bit more detail. But 2C talks about impacts and effect. How does this thing affect society, right? So you want to make sure that when you're choosing an innovation that you can actually fathom some sort of effects that this thing is going to have, right? And then 2D talks about data and how does the device use data? So what kind of information does it take in? What does it do with that information? And then what does that do to the user, and how does that affect it? All right. So once you select a computing innovation, then you are going to conduct research and then you're going to document your sources. So this is important, right? You're going to conduct research. So you're going to search. You're going to look through books. You're probably going to do a lot of search online, trying to figure out what information about this device. You don't really have to know about the device beforehand, but you do need to do some research and understand more about the device as a result of this project. Right? Then I want you to remember that you should document your sources. So you want to make sure that you are keeping track of where you're finding information because you need to reference that particular information. Right? Now, once you've done your research and you've documented your sources, then you're going to do the two major parts of this project. You are going to create a computational artifact. So computational artifact, what is that? Well, it is going to be either a video, some audio, or a PDF. The PDF would be kind of, you can think about it like a digital poster board, right? So like if you were going to take a piece of poster board and you were going to like hang it up on the wall and you were going to put pictures and show what this device does and how it works, that would be kind of like your PDF, right? So now it's important that you know that video and audio must be less than 1 minute in length, and the PDF must be less than 3 pages. A lot of students, when they make these, they try to make the PDF just 1 page that kind of shows all of the details that they want to share, right? And then after you create computational artifact, then you are going to provide written responses to the prompts, right? So there are prompts 2A through 2E, right? And I'm going to go through in great detail what those particular prompts are. All right. So let's go over to the directions that I was referring to. All right. So this is page 3 of that particular link that I was referring to earlier. So this is the computer science principles assessment overview. So obviously we've got the explore task, the create task, and the end of course exam. Obviously we're not having the end of course exam, so you really want to focus on doing well on the explore task and the create task. All right. And so now if you go to this link, you can read through some of this stuff, all right, which talks about what you should be preparing for. All right. But specifically, all right, we want to go down and we want to think about a couple things. Now, number one, plagiarism. Okay, very important. Okay, a student who fails to acknowledge through citation, through attribution, by reference, and or through acknowledgement in a bibliographic entry, the source or author of any and all information or evidence taken from the work of someone else will receive a 0 on that performance test. So this is very important. This is where I said you needed to document sources. So when you are finding information about your particular computing innovation, you need to document where you're finding this information so that you can refer to the particular sources where you got your information, right? So that is one very important thing. All right, now if we scroll down a little bit here, programming language, that doesn't really apply to this project. All right, that applies to the create project, which is covered in a separate video. All right, peer-to-peer collaboration, very important that you understand. For the explore performance task, okay, collaboration of any kind is not allowed. This is a project for you to complete by yourself. All right, for create there is some allowed, and that will be discussed in a separate video. All right, so continuing on to page 5. So preparing for this. So before you actually start completing the explore performance task, all right, you want to make sure that you understand all of the details. All right, which hopefully this video is helping to do. But there will also be other videos available that will help you to understand some of the details. All right, you can practice. All right, you can review the scoring guidelines, which we're going to do in a little bit. All right, you're going to examine examples of performance tasks, which are available at that link that I showed you earlier. All right, pay attention to the instructions, which is what we're going to be doing right now concerning the size of files. All right, and the length, of course. All right, ensure that you know proper way to evaluate and appropriately cite a source. All right, so we'll be discussing that a little bit today as well. All right, and a few more details here. All right, so now let's go down. All right, and now we're accessing the specific details related to the explore performance task. All right, so the explore performance task is meant to help you to show that you understand how computing innovations impact our lives. And why is this important in computer science principles? Well, the impact of computing innovations is very important to show that you have an understanding of the principles of computer science. All right, so what you're going to be doing is you are going to be spending 8 hours of time. I don't know if you want to consider class time if you're working on it at home this spring, but basically you're going to spend about 8 hours of time to develop, complete, and submit a file. All right, so there are 2 things that you are submitting ultimately. One is the computational artifact, which we'll talk about in a little bit more detail, and then the written responses. Okay, so those 2 items you are going to be submitting, and there will be a separate video later on that will outline how you're actually going to submit those things. All right, but anyway, scoring guidelines and instructions for submitting your performance tests are available on the AP Computer Science Principles course homepage, which is the link that I showed you earlier. All right, so now let's keep moving down. All right, general requirements. Okay, this performance task requires you to select and investigate a computing innovation, to analyze a computing innovation's impact on society, economy, or culture, and explain how this impact could be beneficial or harmful. All right, so this is really the big idea here. You want to find a computing innovation, and you want to make sure that you understand how this thing could impact our society, economy, or culture, and what sort of beneficial and or harmful effects this thing may have or has already had. All right, you also want to make sure you understand how a computing innovation consumes, produces, or transforms data. All right, describe how the data storage, data privacy, or data security concerns are raised based upon your capabilities, on the capabilities of the computing innovation. All right, so now you are also required to investigate your computing innovation using a variety of sources, print, online, expert interviews. Many of you will have primarily online sources. You are to provide in-text citations. This is one very important thing. When you are writing, so-and-so said such and such, you want to make sure that you actually, in the text, that you're referring to the particular source that you have. Right now, there must be at least least 3 different sources that help you create your computational artifact and or formulate your written responses. At least 2 of the sources must be available online or in print. Your third source may be either online, in print, or a personal interview. At least 2 of the sources must have been created after the end of the previous academic year. So we are looking for something that was created after June 1st, 2019, right? And so within the last academic year, right, you're to produce a computational artifact that illustrates, represents, or explains the computing innovation's intended purpose, function, or its effect, and provide written responses to all the prompts. Okay, so I'm about to show you the prompts, but okay, the computing innovation's intended purpose. All right, so what does purpose mean? So a particular company or individual created this computing innovation. Why? Well, that's what the purpose is. Why does this thing exist? So you want to make sure that you talk about why this thing exists. The function is how does it accomplish its purpose? What does this thing do so that its purpose is achieved? Right? And then its effect. What is that? Well, the effect is something that if I'm using this particular device or this innovation, the way that it was intended to be used, what is the byproduct? What do we see as a result of using this thing as was intended? Right? So now the submission requirements. First, the computational artifact. Your computational artifact must provide an illustration, representation, or explanation of the computing innovation's intended purpose, its function, or its effect. So you are to create either a video, audio, or like I said, like a digital poster board that shows what this thing does, how it does it, or what effect it may have on individuals or society, economy, culture, whatever. Okay? The computational artifact must not simply repeat the information supplied in the written responses. So remember, you're not just like copying and pasting the same text. This should be some images or some video or whatever that shows what this thing does. And remember down here it says, and should be primarily non-textual, right? So it shouldn't just be a paragraph of text. This is something that would help people understand how this thing works or what it does or what effect it has, right? So now you're going to submit either a video, audio, or PDF file, right? And you're going to use computing tools and techniques to create one original computational artifact. All right, now remember, acceptable multimedia file types include M3, MP4, WMV, AVI, MOV, WAV, AIF, or PDF. These are the file types that you must upload. So remember, if you have a different type of file, then you have to convert it into one of these. And that would be discussed in a later video when we're getting ready to submit. PDF files must not exceed 3 pages. Video or audio files must not exceed 1 minute in length and must not exceed 30 megabytes in size. So remember, once again, if you have a file that's too long, you need to trim it. Or if you have a file that's too large in terms of its size, then you'll need to convert it to a lower quality or something so that it will be the right size. Okay, when you go to upload, the system will not accept a video that is longer than 1 minute or a file that is larger than 30 megabytes. All right, so now written responses. What are you actually responding to? All right, so you're going to submit a PDF file to the prompts 2A through 2B. All right, now total, it says your combined words must not exceed 700. So this is really the entire thing. So you want to make sure that you're being descriptive but concise. We don't want 10 pages of text here. We want to make sure that you can succinctly describe what you need to do to hit these prompts. All right, so continuing on down here. All right, so computational artifact. All right, so in 2A, this is the prompt that you are writing. So now remember, you've already created your computational artifact, your video, your audio, or your digital poster board, like I said, and then you are going to, in 2A, you're going to talk about your computational artifact. All right, so what do you do? So you're providing information on your computing innovation and your computational artifact. So number 1, okay, this first bullet here, you are naming the computing innovation as represented by your computational artifact. So you're going to say, in my computational artifact, I show the such and such. So give it a name. All right, the reader is not going to infer what the name of this device was or application or whatever. All right, next, describe the computing innovation's intended purpose and function. Right, purpose and function. Notice here it doesn't say something about effects. Right, so purpose and function. Remember, the way I think about purpose, why does this device or application or whatever exist? Okay, and then how does it do it? What does it do? All right, so that's what you're describing into it. So this is the name of my device. This is why this device exists, and this is how this device functions. Okay, then also be very clear. Describe how your computational artifact. So now you're going to say the computational artifact that I created shows this. Right, so it illustrates, represents, or explains the computing innovation's intended purpose, function, or effect. So all you're doing is simply trying to explain what you were trying to show in your computational artifact. Right, now this says must not exceed 100 words. So remember, you're trying to be concise and succinct in your description. Right, so that is 2A. All right, next 2B. Describe your development process, explicitly identifying the computing tools and techniques you use to create your artifact. Your description must be detailed enough so that a person unfamiliar with those tools and techniques will understand your process. So this is very simple. All you're saying is I went to Google Docs and I opened a blank document and I inserted these images and that I found on such and such a website and all of this. So you are just outlining what you did to create your computational artifact. So 2B is not talking about the computing innovation. You're talking about how you personally created your computational artifact. How did you create your video? How did you create your audio? How did you create your digital poster board? Okay, once again, must not exceed 100 words. All right, next, okay, in 2C and 2D, you are talking about your computing innovation, okay, not the development process. All right, so you are going to explain at least one beneficial effect and at least one harmful effect the computing innovation has had or has the potential to have. Now remember, has the potential to have. Some of these devices don't even exist yet. A company is working on this device, and so we can't say like it has already done this. Well, because it hasn't even come out yet. So you might have to be creative here, thinking about what potential this device has. But remember, has the potential to have on society, economy, or culture. Right? So must not exceed 250 words. Right? So obviously you got a little bit more. Now you want to make sure that you are specifically saying this is a beneficial effect or a positive effect, and then this is a harmful effect or a negative effect. You have to make sure that you are defining beneficial effect, harmful effect. Now remember, what is an effect? An effect is if I'm using this particular device as it was intended, the way it was created, the way the manufacturer said to use it, what is the byproduct? What is the unintended result of using this thing? Right? So that is very important that you understand that. All right. And then 2D, using specific details, describe the data your innovation uses. Right? How the innovation consumes. So how does it take in, produces as output, and or transforms data, and at least one data storage concern, data privacy concern, or data security concern related to the computing innovation. So you need to say, hey, this particular device, in order to use it, you need to give it this information, or a particular device takes in this information. So you think about maybe smart devices. What type of information do they take in? Right? So that's talking about like consumes, right? Produces. So once it takes that in, what information does it put out? What does it give out? What does the user see as a result? And or transforms. And so then what type of action, maybe, I don't know, whatever happens when you use this particular device, right? And then data storage, data privacy, or data security. So if I'm using this device and it takes in this data, is there some concern that I have as a user about what is being stored, or is it sensitive information? Is it personally identifiable information? Or is there some security concern with how it's connected to the internet, or what it accesses? Okay? So once again, must not exceed 250 words. All right, so those are the writing prompts, and then lastly 2E is the references. Remember earlier I talked about making sure that you are documenting your references. So provide a list of at least 3 online or print sources used to create your computational artifact, and or support your responses through in-text citation to the prompts provided in this performance test. So remember, in your 2A, 2B, 2C, 2D, you want to make sure you are citing the sources that you are listing in 2E. So remember, 2 sources must be created after the end of the previous academic year, and then here is a little bit more information about those. Okay, all right, and so that is the Explore performance test. All right, now there's a little bit more that you want to read through here. All right, but I want to switch over and make sure that we talk about the next piece, the scoring guidelines. So once you complete all of your written responses in your computational artifact, then how is it scored? All right, so what we want to do is we want to go to this link, right, which is available on that earlier College Board website that I showed you earlier, right, on pages 5 through 7. Okay, so what we want to do is we want to make sure we understand exactly what the readers will use to score your response. then use that to use the scoring guidelines to store sample responses to develop a better understanding. So there are some sample responses that a later video is going to show you how to do. But basically, we want to go through and look at samples and say, hey, did this person score the point here or not? And so that we understand how the readers are going to use these scoring guidelines to grade your particular submissions. All right. And so let's head over to this. Okay, these are the scoring guidelines. All right. And so we want to make sure that we understand how these things are being scored. All right. So there are 8 rows that are being scored for the Explore Performance test. All right. So I'll refer to the row 1 and then what part of the task we're looking at, and then what are the scoring criteria. All right. So now I'm not going to go through all of the decision rules, but these are really important to read as you are thinking about how your particular thing is being scored. All right. So row 1, we're looking at the computational artifact. All right. So the scoring criteria says, does the computational artifact identify the computing innovation? So does it have a title? Did you put the name of the computing innovation in? Okay. And notice it says and provides an illustration, representation, or explanation of the computing innovation's intended purpose, function, or effect. All right. So we want to make sure we understand. Have you actually provided this illustration? Okay. So that's what row 1 is. Now all of these are graded on a binary scale. Either you get 1 point or you do not for each particular row. There are no half points. Okay. So we want to make sure that you guys understand that. All right. So now, okay, the decision rules. It's very important that you understand these decision rules. So you want to read through these. All right. So you're not going to get the point if there's no artifact, or if it's not a computational artifact, or the innovation identified in the artifact doesn't match the innovation described in the written response. So if you mention like a particular application in your computational artifact, and then you go and you're talking about some device that is not the application you described, then you're not going to get this row. All right. The artifact does not identify the innovation clearly. The artifact does not illustrate. Right. So you want to read through these in some good detail to make sure that you understand that. And like I said before, we will go through some samples in a later video. All right. All right. Now moving on to row number 2. All right. Response 2A. All right. So response 2A says states a fact about the correctly identified computing innovation's intended purpose or function. Okay. Now you're supposed to address both, but okay, when you have stated the intended purpose or the function, then you're going to get the point for row 2. Now it says do not award a point if the identified innovation is not a computing innovation. So if in your computational artifact you showed a picture of somebody making a ham sandwich, and then they were in another picture they were eating a ham sandwich, you're not going to get any points for row 2 because you have not identified a computing innovation. Okay? All right. And then here the written statement gives an effect which is required in scoring row 3, not row 2. So if you said, hey, I have this ham sandwich and the effect of it is that it's going to make me full, right? Okay, that is not the purpose, right? That is the effect of the ham sandwich. Obviously, the ham sandwich isn't a computing innovation, so you wouldn't get that point. But hopefully you understand. Remember, if you say the purpose of this device is to do X, Y, and Z, right? That's what you are claiming as the purpose. You want to make sure that you are not also claiming that as an effect. All right. So that is row 2. Right. Row 3. All right. Now we're looking at response to C. So now very important. Response to A, response to C. Where is response to B? All right. Well, response to B is not one of the rows. Response to B is used to verify that you have actually created your computational artifact. It's not just something that you copy off of a website or something else. So you need to make sure to B gives an accurate description of how you created your computational artifact. All right. But anyway, row 3, we're looking at response to C. All right. So you have identified at least one effect of the identified or described computing innovation. So row 3 is a kind of an easier point to get. You said if I use this device, which is intended to do this, this will happen as a result. So that is stating one effect. Okay. Now to get row 3, you don't need to describe that it's beneficial or harmful. Right. That is in row 4. Right. So this is kind of an easier point to get. And then row 4, if I go down, we're still looking at response to C. Now we've identified a beneficial effect and a harmful effect. All right. So very important to understand. If you got row 3, you may not get row 4 if you haven't defined one of the effects as beneficial and the other or another effect as harmful. Okay. Now very important to remember. Okay. If I go back up to these decision rules. Okay. Obviously, if you don't have a computing innovation, you're not going to get this one. All right. The identified effect is actually a purpose. So in 2A, if I said, hey, the purpose of this device is to do this, and then in 2C, I say the effect of this device is that it does this. Right. That was the purpose that I defined. So you're not going to get the point for effect if you said that that was the purpose of the device. All right. So for instance, this device allows me to make videos to share with my family. Right. So if that is the defined purpose, then we can't say the effect of this device is to allow me to share videos with my family because you stated that that's the purpose. Okay. All right. So now remember, also I said this earlier, the identified effect is not a result of the use of the innovation as intended. So when we say, hey, this is what the device is intended to do, but then you can't turn around and say, well, there could be problems if the device doesn't work properly, or somebody hacks the device and then they cause it to fail. Right. That is not the way the device was intended. So that is not an effect of the device. So make sure that you understand. You never want to talk about like exposure to hacking as an effect of its intended use because that is definitely not an effect of the device. All right. So moving on to row 4, let's continue. All right. Remember, you had to identify beneficial effect and harmful effect. All right. But now here's the key. All right. The response, you do not award a point if the response is missing the adjectives harmful or beneficial. So you have to make sure that you say this is the beneficial effect or the positive effect. This is the harmful effect or the negative effect or something like that. All right. Now the other thing, the response is missing a plausible beneficial effect or a plausible harmful effect. You can't give something totally ridiculous. You can't say like, hey, if I eat this ham sandwich, I'm gonna grow wings and I'm gonna fly away. Right. That's not plausible. Right. So you want to make sure that you give a plausible effect. It has to be realistic, something that could actually happen as a result of using the device as it was intended. Right. All right. So let's continue on. All right. Row 5. Okay. Response to C explains how one of the identified effects relates to society, economy, or culture. So this is bigger than just the effect. So you say, hey, if a user uses this, this is the effect that it will have on them. Okay. That's an effect on an individual. But now, how does that ultimately impact this greater group of society? So how do we say, okay, well now, if a bunch of people use this, this is what's going to happen to society. All of these different things are going to take place, and society is going to be worse overall, or better overall, or change the way we do things. How's it going to affect culture, or the economy is going to skyrocket as a result of this? All right. So you got to make sure you connect it to one of those. Okay. All right. Let's go down to row 6. All right. Row 6. Now we're looking at response to D. All right. So scoring criteria. You have identified the data that the identified or described computing innovation uses, and explains how that data is consumed, produced, or transformed. All right. So when you talk about your particular device or application or whatever, you need to make sure you talk about what type of information does it take in. You can't just say it takes in data, right? You can't talk about data in general. You have to talk specifically what does this take in. Now, you also want to make sure that you don't confuse the source of the data with the actual data. So let's say that a device has a camera on it. Okay? The camera is the source that is taking in data. But it doesn't, if you say like, oh, it has a camera, it doesn't actually say what the camera takes in. What does the camera take in? It takes in an image, right? An image is a data type. So you can see over here in scoring notes, data types include integers, numbers, booleans, text, image, video, audio, signals, right? Data that infer types like fingerprints, temperature, music, length, pictures, etc. These are all allowed, right? Data collection device, sensors, cameras, those are not data. So you want to make sure you talk about what it actually takes in, all right? All right, so that is row 6. All right, row 7 to D, once again, identify the data storage, data privacy, or data security concern related to the identified or described computing innovation. All right, so remember, okay, you want to talk about, okay, if this device takes in this particular information, am I concerned as a user about the amount that it has to store or what it's actually taking in? Is it personal identifiable information? Do I have some concerns with the security of the device and what information could get out there if somebody were to get control of this device? All right, now it's very important that you remember, okay, in both of these, okay, the responses are evaluated on the rationale that you provide, not for interpretation or inference of the person who's actually reading your response. All right, so make sure that you're very detailed and you give information. All right, and then lastly, row 8, you're looking at response 2E, all right, and the entire artifact and written response. All right, so remember, row 8 is about your references. So have you, through in-text citation, given at least 3 different sources? So So in 2E, you need to list 1, 2, 3, 4, 5, whatever your sources that you use to create and formulate your responses. But then you must go back in your 2A, 2B, 2C, 2D and give in-text citation. So you have a particular sentence that you used some information that you read somewhere. Make sure that you cite that in text. All right. So that is the scoring guidelines. All right. So let's go back here. All right. So now, okay, debrief and summary. What did we just do? Okay. You should understand the general requirements of the performance tasks. You should understand the specific requirements of the Explore. You should know what to do to get ready for the Explore. You should know what to do in order to complete the Explore performance task. All right. You should know what you need to submit, and then you should know how it's going to be scored. All right. I appreciate you joining me. All right. Now, please understand that the College Board is aware that not all students have access to the internet or device. We're working on solutions to help students get what they need to show their best work. If you need mobile tools or connectivity or know someone who does, you can reach us directly to let you know. So please access cb.org/tech in order to do that. All right. So thank you so much for watching, and I hope that this was helpful.